Welcome! And I forgot the light. Yay! Welcome to part one of my new project, which will be to design my first printer. I think it will be quite a fun experience. Lots of stuff to learn, and basically my goal is to make it as cheap as possible. Which, yeah, I don't know. Like, I'm not sure if I can really achieve the goal of the project, I would say. So I just don't want to spend as much money for the parts in the beginning, and let's just see the small trial. But I think it actually will be more fun just having the restriction of not just buying parts. So basically what we need to achieve is needs to be as simple as possible from the bill of materials. So that means ideally one or two kinds of screws, super common things you can maybe get even in the hardware store, and not a lot of parts. So yeah, that's it. So today, basically, I just want to quickly do a sanity check on the concept I have. And basically to hit this sub 100 euro price point, there is really not a lot you can use. From parts perspective, from motor perspective, this is really the only choice we have. And this is a super common stepper motor. I think I've read that they're used a lot in cheap appliances and stuff like that. They are of course not very strong, but Thomas Salandra, Made with Layers, I think is the new channel name, reviewed actually also sub 100 euro printer on his channel recently, and I think they use exactly those motors for that printer as well. So I think it's possible. We will need to tune them a bit though, and that is kind of the goal for today. It's just to figure out whether it's really feasible to use those motors, and whether we can drive them with a regular printer mainboard. Yeah, so it's kind of the goal. And then as a secondary thing, I actually designed the first parts of the printer. Doesn't look like much, but took me quite some time so far. Show that. That's not it, that's a V0. Yeah, but basically that's what I designed so far. So basically it's just the XY joint, where the X-axis meets the Y-axis. And it's just my trial part to prove to myself that I can design it, but also just to validate the concepts I have. So basically what we will use to put everything together, not to kill something, are those super cheap aluminum rods. They're basically hollow inside. This piece is 1 meter and costs €2.50 or something, so it's really dirt cheap. And they are quite stiff. Yes, you can bend them now here from the ends, but I think if it's a shorter section, it will be quite stiff. I also use two on top of each other. So you see here basically the y-axis is two of them and the x-axis is also two. And then they just get clamped in those blocks basically. So that's my idea. And for the motion system basically, what we will do is we will 3D print little bushings basically. Seemingly people use them actually on printers, at least that's what I saw online. And they run quite smooth. They don't have a lot of play, and they run really smooth. So I think that will work. I'm a bit concerned about wear, but it's not really supposed to be a machine that you use for your daily print jobs. It's really just fun to build. That's my main goal. Cool. Yeah, so for today, basically we will just throw that stuff together. This is just a Raspberry Pi Zero in a case, and this is a somewhat broken mainboard. For those who saw my Switchwire series, this was the mainboard where we blew the X stepper. So this one is kind of done. But that's why we use it for experiments with modified stepper motors now. If I blow another stepper, it's, yeah, doesn't really matter. For the final printer, we will actually use an Ender 3 mainboard. The reason is that you can get those on eBay for 5 to 10 euros. They're yeah, super cheap. I bet there are also a lot of people who just have one lying around. as I have. Because at some point you just like swapped out your mainboard of your Ender, and then you have like this like random mainboard there, which you can't really use for anything. So that's what we will use as the brain of the printer. But yeah, today, because I don't want to blow up the stepper on this one, we will experiment with that. So basically, I flashed mainsail OS on here, and this one is already pre-flashed with clippers, so we can kind of like use that for now. And then my goal basically is to modify those steppers. So by default, by the way, the stepper is like €2. So 5-pack you get for like €10 on AliExpress, so they're really cheap. It's the only qualification those things have. So they run on 5 volts. You can overdrive them basically with 12 volts. So we will also drive the mainboard with 12 volts later. And then my understanding of stepper motors is like limited, but these are unipolar motors, meaning the 2 coils are connected. So if you compare this stepper with like a normal stepper you would have on your 3D printer, you see here basically that this one has 5 cables. Normal steppers, normal in air quotes, only have 4 cables. And the reason is that there is like this red cable in the middle that connects the 2 coils. So basically you have 2 cables per coil, like, I don't know, like most likely those are 1 coil, and the other 2 are 1 coil, and then you have this red cable that connects the 2 coils. That seemingly makes it easier to drive the motor, which for cheap motors is amazing, but we have proper stepper drivers here, so we don't need that convenience. So basically what we need to do, as of my understanding, is on this PCB, you see like there's this like trace in the middle. There's this trace here in the middle connecting this pin and that pin. And if we sever that, we will split the coil. So then we transform this motor from a unipolar to a bipolar motor. And that makes it stronger. Harder to drive, but much stronger. So basically we'll just cut the trace here on the board, and then we can remove the red cable because it's useless at that point, and it leaves us with the 4 cables we then connect to our mainboard. So that's the theory. You see, like also here we have like four pins. That's the theory. And then basically we'll see if we can drive this motor with the printer mainboard, and we see if we can drive it with 12 volts. I saw some article online where they basically did like tons of testing, and they actually figured out that 10 volts is the optimum. So if you use 10 volts on those, seemingly it's the ideal voltage. You get the most torque out of them. But maybe it's something we can also like try out a bit today, like very rudimentary testing. And then basically I have a 12 volt power supply here. That's like 30 watts, so it's like more than enough. But we can also put, which I would need to get, but we can take a buck converter and like reduce the voltage a bit just to like play around. And yeah, that's kind of the whole thing. So I would say let's just get started and stop the talking. The only thing I'm a bit concerned, I don't have a USB-C power supply. Oh, I do. Wait. Wait. I don't see what I'm doing, but there's things I could have done before the stream. It's plugged in. Okay. This now has adequate power. We might get like under voltage on the Pi, but let's see. So basically, let's just quickly connect that. And yeah, the Pi is on. You see the green LED. Yeah. Okay. And there's the red LED. So this is the most simple printer setup ever. Who needs all those cables? So basically, like to draw, like use this in the setup, like we need to like cheat Clipper a bit. I think most likely it will freak out immediately, saying like there's no temperature sensor. I didn't work on that a lot before. I just copied the configuration for this file for this board on the Clipper and made sure they see each other. But that basically is all I did last week. So let's just quickly jump to the browser. Oh yeah, and the V0 is printing another one of those, so we can try it out later. I think I called it test printer.local. Dash. Yeah. Oh yeah, arrow. Here we go. Oh yeah, exactly. That's what I remember. ADC out of range. Heater temperature exceeds. I was actually doing some Googling. And the trick is in the min temperature, which is 0 by default. Because basically there's no resistance, the temperature is super, super low. So basically the higher the temperature, the more resistance you have. So basically the less resistance you have. Because there's no connection between the two cables, the resistance is very, very high. So the temperature is super low. So let's just put something like -200 there. Most likely, let's see if it works. So we just allow the printer to be super cold. And then hopefully this will just allow us to bypass this error state. Oh, yeah, that was easy. Oh, yeah, you see. Oh, you don't see? Oh, there you see it. It measures like -60 degrees at the moment. Cool. Yeah, this is our like printer. So I think this works. Then let's just start with modifying the motor, I guess. This should be quite quick. The bigger part is we need to crimp a new connector at the end that we can plug it in. So and technically we just really need to cut this trace here. I'm just digging into the board a bit. The beautiful thing is that even if we screw it up, they're so cheap. I have like 5, so one can be broken anyways because we only need 4. Although like one thing I thought about is like using more than one stepper per axis. Just that you can have like a bit of boost. Let's see, so technically this should already... Yeah, there's no connection anymore between... Oh, there's still... Huh. Still connection, okay. That's weird. No, it's gone. No, nothing beeps. Okay. Nothing beeps anymore. Then I guess we can also just cut the cable. Just pull it out. And then maybe we can, yeah, let's just put this cap back. see if we can fiddle this back on. Actually, like something when we design the motor mount at some point, maybe we can just design it in a way that the cap is not needed, that you can just like really pull it off, and the motor mount just covers the PCB a bit. Okay. This doesn't want to. I guess then it stays open. Okay. Whatever. So then let's also cut off the connector. The only thing I'm not quite sure is like the order of the cables. I mean, the red one is out anyways. And for the others, I'm not quite sure. I guess we just try it and see what happens. Here we go. A new bipolar stepper driver is born. Stepper motor is born. Oh, let's do our most favorite thing in the world: crimping some connectors. So we need the 4-pin housing, and I need to order DuPont connector crimp thingies. I'm running a bit low. We use a lot of those. Oh. I also smartly arranged my tools this stream, so I don't have to like reach all over there to grab something. Slowly learning. Those cables are really horrible. That was a bit. Ouch. Okay, let's see how they crimp. Okay, definitely the small side, small. Okay. Doesn't crimp on very strongly. So I already used the smallest size of my crimping pliers. Let's try the following. So basically, normally the casing should end here. So it's like really small. The casing should end here. I just move it a bit more forward, that the tongs on the front grab on the casing as well. Let's see if it helps. Oh, that was. Should fit already. Yeah, that's better. I think the connection is still okay, most likely. Let's see. Let's maybe do like a halfway. It's like the forward tongues are like grabbing a bit on the casing, but also on the wire a bit more. By the way, last week I had like a frame drop. If you see anything that like the stream is like stuttering or something, just let me know. I think I fixed it. Zoom a bit out so I'm always having something in frame. Okay, last one. Maybe it would have been smart to crimp them as DuPont connectors. Because then we can like quickly switch them around. Maybe let's actually do that because I don't like, no, they're not well connected now. Because like, yes, the casing is on, but they're not well connected. Let's crimp them as DuPont. Let's do that. And then we just use jumper wires to connect the stepper drivers. Then we can like quickly like try out different cable combinations if we have problems. I think that's the smarter approach. So basically we just used single DuPont. And here we have the oh, that's embarrassing. I crimped DuPont on them. In my mind, I crimped JST because I also took out the JST housing. So we had the correct connector already on there. Hey. Okay. Well, that was stupid. Probably enjoyed crimping. So let's do it again. But let me also quickly grab already jumper wires because I'm not sure which male-female combination of jumper wires I actually have because I don't have a lot at the moment. Let me quickly grab them, then we know if we need to crimp female or male here. I'm right back. Okay, back with jumper wires. I have male to female. We need female here on the board. So we also need female on the wires here, so that works perfectly with what we have. I just grab like already 4 cables. Will be a bit of a color fest, but will be fun. Then let's do this again, and this time we also pay attention again that we only crimp the weight intended. I'm just like, it's really weird to crimp those cables. I mean, worst case we need to solder a different cable onto those. Let's just double crimp that. Yeah, not on properly. and the isolation, the casing ends before the second pair of like tongs that you crimp. So now the electrical connection is good. It all seems to be on somewhat properly, or somewhat okay. So maybe double crimping is the way to go. Hey. Yeah, definitely not my favorite cable to crimp. Okay, that's also on an acceptable way. Let's see if we get this done 2 more times. Oh, I was wondering why nobody was chatting, but I was looking on the wrong chat. Oh, that's awkward. Here you go. Let me also put it here. Hi, Jordi. Hi, Vixitors. And hi, Alex. Wait, I have to quickly sort stuff. I must have copied the wrong chat URL. Ha! Way more fun with the chat. Let's put on the last. Okay, that's all of them. So, then maybe let's do some quick like online research, stepper driver cables, and what order they should be on. But I also have actually like a NEMA 17 stepper here that we can use to compare. And the last one. Okay, we have 4. So it's actually like a good idea. I do have this Creality stepper here that is actually intended to go for into the switch wire main, switch wire y-axis. It's like an upgrade at some point that we can do. I'm just not sure if I also have a matching cable. I don't think so. No. That would have been too easy. If we could have just copied that. But I guess always two of those wires should have continuity, right? Like we have two like coils in there, and each coil should have continuity. So basically like the start and the end of the coil should have continuity, right? That's at least my rudimentary understanding. So yeah, so orange. So the outer two are connected. Like pink and orange are connected. And then blue and yellow should also be connected. Exactly. And we don't have continuity between the two. That's by the way, like just like for comparison. Wait, here's the second one. So this is the unmodified one, right? The one that we didn't take apart. And I think here all cables have some form of continuity. Yeah, exactly. See, continuity, 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 continuity. All of them are connected. Because of that like little bridge here that we like eliminated on this board. So this is unipolar stepper, and this is bipolar. I'm still not quite sure if I understand all the stepper stuff, but that is what I understood. Cool. Then, wait, we said orange and pink, and blue and yellow. Then let's quickly do some online research. I moved the board and it lost the connection. Let's just look for SKR Mini E3V 2 pinout. And then basically like, I mean, the X one is blown on this board. So let's just use Y. 2B2. So I assume 2 is the... Are the two B's one coil or are the two A's one coil? I guess it would make sense if those two are one coil and those two are one coil, like the A's and the B's. Stepper, driver, pinout. Let's just, I assume that like that's quite a common thing how to name them. Yeah, see here, 2B, 2A, 1A, 1B. The upper channels are broken out to the side. But how do we connect them? And here it just says the colors. But it helps us actually because we conveniently have a NEMA 70 stepper here. So they say that here we see black and red. So 2B and 2A. So they have the 2's here. And the 2's are not the same, I think. Let's just quickly check the continuity on this stepper here. So it's the outmost 2. I don't get continuity across the outmost ones. And I don't get continuity across the middle ones. Ah, okay. So that's basically how it's shown here. I mean, it makes sense. The two red ones and the two black ones are one spool. So that means that the red on red and red on yellow, they go to 2. So the B and B are the same, correct? So the topmost, oh, 2B goes to 1A and 2A goes to 1B, right? Because like here they are in one line. So this one, so the two red cables go, so it's red, black, red, black. Red, black, red, black. Yeah, 2B goes to 1A and 2A to 1B. Very confusing. Okay, what does it mean for us? If we go over here, so we know that we basically have to mix them. So we basically have to mix them. It's always one of each. So it's the blue, which goes with yellow. Those two are like connected. And then we just take the orange one. And then we take the yellow one. So that's the matchup we now have. So basically on the end here, if I sort that, like those should be continuity exactly, and those. Yeah, so that's at least correct. Now I'm just not sure the direction of flow, right? Like one of the two is positive and one is negative. And the direction of the flow, of course, determines the direction of the magnet field, right? Of the magnetic field. So it could be that they're just in the wrong direction now. But nevertheless, like this is something we can work with. So let's just rudely disconnect that. We also need to set up power here, right? So I have this connector thing here. We just need to like wire proper cables here. I wouldn't. Technically, we can use jumper wires. Now let's use something a bit more substantial between those two. I don't think it's really needed with one of those, but see, this one would work. Yeah, it's just use just this wire here. Is that the same? Yeah, I think so. That's like 18, 20 gauge, something like that. That's good enough. Also doesn't have to be like super long, right? Do this. It's all just for testing. Then we have little markings here. So the left one is the positive. With tech test. And that's the negative. Okay. And then I remember the outside one was the negative, but I mean, we have the pin out open here, right? So let's just check. Outside one is negative. Let's hope the board works with 12 volts as expected. That should be. Like, I'm pretty sure that they work with like 12 and 24 volts. Because, for example, the CR10, for example, works with 12 volts. And I'm pretty sure that they're just like compatible. If not, we will find out now. Okay. So this would be ready. Sorted in some logical way. So basically, when we connect that, we are live. Let's just hook this up. I mean, we have 3 more steppers to burn. Okay, let's connect it. I'm sure, maybe, do I have some tape? Let's add a little like flag here that we can see when the stepper turns, or like see it more clearly. Don't have any tape here, I think. Oh, there. I mean, it's not gonna turn like right away, but gotta be prepared, right? Now we have this like little thingy here. Which should turn at some point. So let's connect that. So quickly clean up a little bit, just like collect all the. I'm still like, I really need like a trash bin here. It's like a small like thing where I can collect stuff like this. I mean, this and this we will reuse. Here for the rest. Let's go over here for now. Okay, I guess moment of truth. Let's connect that. We have more LEDs now. So let me just put this here. And I guess now it's just time for the software. Let's see. Takes a bit longer than usual. But given that the connection was locked before when I moved the Raspberry, I don't think the cable connection is super stable. So let's not touch that too hard. Okay, so we connected that to Y. There's a stepper bus. Exactly. Stepper equals Y. Let's see what happens. Nothing. Amazing. Okay. Oh, because 2 cables are out. That's not good. Let's go in emergency stop quickly. Disconnect power. Yeah, it's the downside of the DuPont connectors. They're not really like in a mood and staying in. Okay, let's be really careful with that. Now, chances also that the stepper here is not good, because like this one is definitely not good. Let's restart it. And I just run the same stepper bus command again. Nothing buzzing. Oh. Unknown stepper Y. Well. Nothing can buzz then. Let's just quickly check. Does it maybe need stepper underscore Y? Stepper underscore Y. Shutdown. Short to ground. Okay, so that didn't work. I also figured like maybe we should like quickly adjust the amperage here. That would actually have been smart. Because here the run current 0. Oh no. Oh, if I press the wrong button, nothing happens. 0.5, let's just put that to 0.1. 0.05, like just like really low. Because like this run current here assumes you have like steppers. But we have steppers. Let's see, stepper Y. Here's 0.05. Here's another one. And then just say save and restart. Short to ground. So that most likely means that our cable orientation is not correct. So let's just swap 2. Just swapping the middle ones. Let's try it again. Shutdown. Short to ground. Okay, let's just Google that. I'm pretty sure it's like the cables. 2 wires on my steppers were swapped and causing a short. Yeah, that's exactly wiring issue on that motor. So we have a wiring issue on that motor. I'm very happy to see that it's like not like just like sparking and smoking, but like does something smart. I mean, we can just go the random route. And try some more. Nope. Okay. I mean, there are 16 combinations of those cables, right? So technically we can just try them all out. And we can also try like a different stepper really quick. Just to be sure it's not the issue with this stepper. But now like the cables are mixed up from what we said initially, right? Let's see. Now we are on Z. Oh! Do you see that? It's buzzing. So it was the stepper driver. We can do a small trick, by the way. I mean, you usually shouldn't need that, but you can say set kinematic position x0, y0, okay, y0, z0, and then now it thinks it's homed. No, that's not a command. Clipper. Or it doesn't know that command. Oh, it doesn't know the command. Interesting. Oh, they updated everything, right? Yeah, everything's up to date. Let's see. Can we use set G-code offset? I'm not sure. Let's see if we can use Z. Yeah, must home. Nah, now it says must home axis first. But it's usually what the set kinematic position fixes. Because I don't have end stops. Oh, but we can use force move. I mean, technically we know that it works, right? Because it's buzzing. No. I mean, worst case, we quickly wire up. I mean, we can technically just home Z, right? Now it says that's still triggered after retract. I just want to see motor like spin a bit. But I guess we can fix that by just inverting the end stop. End stop pin is not. So I just inverted the end stop. Oh no, that doesn't work. Oh, it's first the little roof. And then the knot. Okay, now it's happy. So let's home that. It doesn't run smooth. But it runs. So basically the goal now is to make it like you see it's vibrating like a lot. I mean, I will just error out at some point. I just shorted the Z and sub pins with the screwdrivers. Now it's home. You also actually see it like now blue. So Z is home. So now we can move Z. Okay, so basically, the thing with those steppers is like they have tons of revolutions. Let's see. So basically we know on this board that the Y stepper is also bad, seemingly. But yeah, for testing purposes, like I don't really care which one. So we use the Z stepper. So the run current is 0.05 at the moment. That's something we need to address. But then it's also the micro steps. This is like a value we need to check out most likely. And I don't think it's 16 for us. So that's all like a little bit of learning experience. So firstly, from the run current, I mean, firstly, the motor runs with 12 volts, so I'm very happy. Let's just check the micro steps first. Here we go. That's documentation. So the funny thing is, like, those have a gearbox inside. We just need to, let's quickly check the specs for this motor actually. Wait. What's the model number? 28BYJ. BYJ. Steps per revolution. 32. But they also have a gearbox. So we have 32. So let's just punch it in our configuration first. Let's also quickly double check that the disclose stuff we don't need anymore. Micro steps, that is actually what I think it is. The micro motor driver uses this parameter must be provided. Okay, let's just see if we can say micro steps. I see 1/16 here. And it also says motor driver. So let's leave that at 16 for now. But there's a gearbox, which is important. Gearbox. Gear ratio, because I think it's like 64:1 exactly. So this is something we need to provide in the gear ratio. So we need to have gear ratio. Let's see. Oh, this would have helped. Exactly. So you see here, this is like the gearbox. That's 64:1 gear ratio. The operating current. I mean, at the moment we have it super low. We have it at 50. I know from some articles I read that we can go to like 0.2. So let's just do that right away. And let's just see what it does from the rotation, everything. This says the error. Oh, it's not here. Wait, gear ratio. Did I have a typo there? No, that's correct. And then like the format is 5:1. 60. Not that I copied some weird characters there. 64 to 1, so I can restart. Let's see. Maybe there's no gear ratio for like Z steppers or something? Or am I in the wrong? No, it's a stepper. That's a rotation distance. Rotation distance given here. So maybe we just have to like increase the rotation distance by 64. But it's like something most likely we have to tune once we have like everything set up actually. That we just see like how far does it move. Let's see, let's just hold it. Oh, now it's very slow. Very, very slow. Hide echo click. I'm not sure if that was the right direction. Let's do instead of 512, let's do, it was 8, right? So we have 8 divided by 512 is 0.0. Let's see, now it should be like hyper fast, I guess. Something tells me that whatever we do here does not make sense. So let's reset that to 8. Yeah, rotation distance. Let's see, what else can we set here? Oh, no, no quotes? I copied the quotes from documentation. Let's try it again. Thank you. Now it's only whining. No, I don't think that works. Like maybe we broke it now. But I also changed the run current, right? Let's change the run current back again. I didn't know restart. Yeah, save and restart. I'm just confused because it still says homing, but it's definitely not. So we broke something. We broke something. Hey there, Kassad. Let's quickly check what Clipper SKR Mini E3V2. And just check quickly config. And then I'll change some weird stuff. So let's put this back to 0.05. And the end stop pin we need to negate again. Let's see if it holds now again. Yeah, now it works again. So I changed some value, but it's like really like I mean, it vibrates a lot. Might just be like it's quite a shitty stepper driver, so to be expected. Okay, let's do the following. Let's change one value at a time. That's always like a great idea. Let's just put this to 0.15 for now. Oh, sorry. So I just changed the run current to 0.15. Still works, kind of expected. But it's like not running smoothly. And I don't think the vibration is normal because also I can like really easily like push it. Now, I used to before and know that they're not strong, but they're not that weak. So I can just like hold it. So there's definitely some setting here that is incorrect. Let's just with the emergency stop that. So something is not correct. So the rotation distance doesn't matter, right? That's just like for like later in the process, basically. Like it determines like how much the software or the firmware needs to turn the stepper for the printhead to move like certain distance. So that doesn't matter for now. The step pin is from the driver, that's fine. Direction pin is also from the driver, that's okay. Enable pin is also like from the driver. So the motor specific things, let's just like sort that maybe. Things that we don't care about go on top. So that's basically what we need here. UART address, like that's also stuff we don't care. So we have the stealth job. Those things. And looking at the configuration, what else is in here? So we have the rotation distance, micro steps, full steps per rotation. Full steps per rotation. So this might be something that we need to adjust, but also like that's not super important, right? It would just determine like how far it turns. But this is definitely something we need to look at for later, because otherwise all the calculations are wrong, of course. And this defaults to 200. The gear ratio, again, yes, but not important for now. Steps pulse duration might be something we need to look at. The minimum time between the step pulse signal edge and the following unstepped signal. This is also used to set the minimum time between step pulse. Okay. Answer pin doesn't matter. Position, min, position, homing, 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 homing. We don't need that. And then the other section we are interested in, right, is the TMC 2209. And here, like, these are all things we most likely don't care. It's really about the driver itself, right? And like the driver doesn't really matter. stealth chop, I think at the moment it's just off. If the velocity is below this value. Aha, so basically at the moment we run stealth chop because like the speed is always below that. So let's do the following. We didn't change any values, right? I just set that to 0. So we are not running in stealth chop, which we definitely don't want to do with those motors anyway, right? Because like stealth chop creates like performance basically for noise reduction, which we don't know. Well, I mean, what I'm wondering now, did we also maybe screw up the cable? It worked better with without chop than without now. But we changed the cables, and I think we figured out that the stepper driver is bad. So I think the cables might just not correct now. Might not be correct now. Let's see, let's put the stealth chop threshold, just quickly putting that back to high value. Let's quickly work on the cables again. Just disconnecting the power. Like if I unplug this one, the stepper drivers don't have power anymore, so we can work on this. Oh, we have tape. Let's use that. Let's just put those annoying cables to rest. Okay, let's quickly check. So initially we said that those two should be continuity. But now the outside ones are. And the inside ones are, and the outside ones. So I'm not quite sure. I'll also quickly check. And we have continuity there. So if we quickly go back to the pin out. So we had this. Right? And we had the, UNL 2003 pin out. That's the original thingy that comes with that. That's a motor, and like if you buy them, like they're always sold with this like stepper driver. Like it's just a step driver board. Actually, I had to look quite a bit to find one without. So basically we know from this graphic that the pink and orange are connected, which we also confirmed now. Yeah. Okay, so that's how it is. So that means I'm so confused with the A1, B1, 2A, 2B. So it's very confusing. I think we Googled just stepper driver pinout, right? And we found this one, exactly. And here we said that the same always goes 1, like 1, 2, 1, 2 basically. But at the moment we have 1, 2, 2, 1. So let's just swap the middle two. No, it makes no sense. We don't swap the middle two. We swap the left two. Because now we have 1, 2, 1, 2. So these two are connected. And these two are connected. Also maybe bring you a bit closer to this like beauty here. So now let's see what happens. So I'm just quickly do a firmware restart just to be sure. And then let's just home. Okay, now it vibrates, but it only vibrates. So I think what happens now is that the two coils work like in opposite directions. So let's swap the yellow and the blue cable. Then we basically change the polarity. So now we change the polarity of one coil. Here we go. Still nothing. It vibrates. It does something. Oh! The cable wasn't really connected. Okay, we really need to pay attention to the cable on the separate driver side. But yeah, it's really easy to like to hold it. I remember them to be stronger. Not faster necessarily, but stronger. And I saw people like lifting 2-kilogram water bottles with them. So they definitely are stronger. So still something is wrong. So if we quickly check the cables again, I just want to make sure the cables are fine. Black and white are swapped. They are in different order on the mainboard. I'm not sure what I would do without you. You are absolutely right. Black and white are swapped. Which means that we are now back in a position where the order isn't correct. So because now basically those two are I'm not in continuity mode, so nothing. Wait, so let me quickly just make sure they're taped properly. And we don't have this problem. So black is on the outside. Okay, then let's quickly check again that we have. Yeah, okay, so we now have this pattern of those two are. Yeah, those two are one coil and these two are one coil. Let's quickly see what that does. Oh, it didn't connect power, but didn't disconnect power. Yeah, it does something, but it's still not. Yeah, it's really weak. Let's see. Okay. If you order them black, white, gray, purple, then should be 1, 2, 1, 2. Yeah, exactly. I'm just wondering, because like the orientation of the 1, 2 also makes a difference, right? So let me just quickly, like the polarity basically of the coil. But I guess if the polarity would be wrong, nothing would happen. So I just swapped the 2 2s basically, or the 2 1s. Let's see. Yeah, exactly. So the polarity was correct because now it's just like it's vibrating, but it's going back and forth basically. So one step forward, one step backward. So the polarity was also correct. Okay, but it means that the cabling is okay. The cabling is okay. That's good to know. Then let's just use the tape here just to secure that. So the cabling is okay. Yeah, like seriously, like now, like when it's powered off, it's way harder to turn than when it's supposedly driving in the opposite direction. Okay. Yeah, I can like really just turn it backward. Not a lot of effort needed. Okay, let's check the configuration then. So let's just check. Maybe somebody configured them. A, B, 2A, or no, B, BA? No, I always forget this. 28 BY, oh god. 28 BYJ. Flipper. Somebody did that. Yeah, but we don't use that stepper. Yeah, it's exactly what we do. So we have this stepper, and we have this bipolar mod basically. Adjusting the VREF on the stepper. You may save time by measuring the current when applying 5 volt to coil corresponding. Okay. Hi, the ballistic tech. What's the degrees? I actually have no clue. That's something we're still trying to figure out. The problem is like there's a gearing, 1 to 64 gearing, and it has, I mean, we can figure it out, right? So it's 360, it's 32 steps per rotation. That's what we know already. So it's 360 divided by 32. 11.25, I guess. So it's quite coarse. But then it has a gearbox. with 1 to 64 or 64 to 1. That's the wrong direction. So it's divided by 64. So that is the value we had before. So that it has like for some reason, like I have the number 2048 in my mind, like something I read somewhere 2048. Let's really see if there's somebody has like a clipper config for that. I was looking for like some configuration snippet or something. Nope. Okay, let's leave that for now. So we have the, oh, what again? 28 BYJ 48 steps per revolution. 32. Oh yeah, see here there's 11.25 degrees. So it's not quite 1.8. The question is just like how does it translate to our configuration here? Because so these are the things, the micro steps. I'm still not quite sure what a micro step is. Rotation distance, again, that's like for later, I guess. It is a 5-wire variation. We made it the 4-wire variation just now. So basically this is the unmodified motor. It has like 5 wires, so it's a unipolar stepper. And we basically removed the red wire, the center one. And on the board, you see here, like we scratched out the connection between the two coils. So now it's 4-wire. Now we just need to figure out how to do it. Turn off microsteps for now. Can I turn it off? Like I'm not quite sure what microsteps are. That's my main problem. Can I put it to 0? Hi to Jonas, by the way. Oh, virtual step. Ah, yeah, I remember. Like it partially puts power on the coils, right? Like to like move the stepper in the middle of proper steps, basically. Let's see. Choice 0 is not valid. Most likely it needs then to be 1. Like 1 micro step per step. Micro steps. Oh, sorry. I'm doing stuff and I'm not showing it. Micro steps 1. Save. It's still turning. It's vibrating more, I feel. But it's still like very easy to manipulate, so it doesn't really like properly step, I feel. Okay, let's see. I'm not sure if that is... And we can leave it off for now. I wonder what it has something to do with the pulse duration. And full steps per revolution we know now is 32. That's what we read, right? So we can... But it's still like the gearing ratio, right? So 32 is not correct. I guess we can put it together, right? 64 to 1 gearing and 32 steps per full revolution. Oh, now it's vibrating very fast. So I think now we just overdrive it. Oh, I see. Ballistic Tech sent me a link. Let me quickly. Let me quickly check that. So that's from Ballistic Tech. Thank you. Yeah, exactly. So here it says it's a we can't drive that because it's like a 5-wire variation, but basically we'll read it like we transformed it into 4-wire. Has very low torque. We know that. Yes, the 5-wire issue is solved. Very low resolution, so 32 steps. Yes, that's also something we know. Yeah, so these are all the problems we are aware of. And the things like I know people use that for printers because let me quickly check that. It is possible. Where do I have that? I think it was this one. So this guy, so shout out to Paul Chase. He built this like mini belt printer and it uses the exact same stepper motors, and he also discusses the conversion. He uses it's a different board, but it's also like a normal printer main board, so it definitely works. It's really just a configuration issue. He went through the same modification, so you can see. I mean, here you see the 4 wires, so also like the red wire is removed. So I know it's possible. It's just like my ability to configure that. It's definitely possible. But yeah, you see here it's the exact same. It's also, this motor has a 12 and a 5-volt variant. And I'm not quite sure how they differ. Because in the end, it's just the coil. So I'm not quite sure what the difference would be between 5 and 12 volt. And you can drive the 5-volt with 12-volt. Like he's doing the same. But I also saw like a lot of like discussions around like how to optimize them. And like 2 years ago, like I bought them 2 years ago, and I was planning on using them on a different project. And I remember I had the exact same like issues. Back then I was using Arduino to drive it. I had the exact same issues with like driving them. They behaved the exact same weird way. And then like I tweaked settings basically, and at some point it worked. So I'm pretty sure it's just a settings issue that we're facing. But yeah, this is actually like a really cool project, by the way. Like it's just like a belt printer, but like as ultra low cost mini. Oh, you found the Arduino script, Jonas. Thank you. Full step is 4, half step is 8, full revolution 2038. Step degree, yeah, okay. But is it 2038 or is it 48? Because I remember 48. But let's quickly compare that with what we have in our like configuration here. Let's see. So, I mean, the full step per rotation. I'm pretty sure there's a typo in the script. Because the... So there says full step 4, half step 8. and full revolution is 2038. But what I mean, I'm not quite sure where we now found the 32 steps per revolution. But if you multiply 32 by 64, which is the gearing ratio here, you end up with 2048, which is kind of what your script has, like 38. I'm pretty sure it's a typo, 34. But then basically that would mean that the script also agrees with the setup we have here, because it also says 1132 degree, right? 1132 times 32-ish is 360. So that the step degree from the script also matches the 32 we have here. So it's 32 full step, but I'm not quite sure if it's a full step. This could be 4. Because like if you look at the, like just like on the diagram of that thing, right? You can only have 4 steps, basically, right? With that setup, because you only have 2 coils. If you do more than... Yeah. 360 by 180, 200. Yeah, exactly. That's the default value also we found in the Clipper configuration. Wait, where was it? Stepper. Ah, yeah, here. Stepper. And here we had the full step per rotation is defaulting to 200, which says for 1.8 degree steppers. Okay, let me quickly check the full step per rotation 4. Let's just see what that does. But most likely it doesn't matter, because like it's just about like how far it rotates, which basically would mean it would be off. Now it does weird things. Heavily vibrating and like barely going back and forth. Everything is connected. So the only thing I changed was the 4. Steps per rotation. Let me return. Like I just returned that to the 8. Or oh, I also added the gearing ratio. The drivers are TMC 2209. Make sure that you first have all fancy path things off. Yeah, potentially. I mean, that fancy pants things. I mean, the gear. Here's the thing. So I sorted that like in a certain sense, right? Like micro steps. I mean, that might be something we need to address. I mean, micro steps 1 means basically it's off, right? Rotation distance and full step rotation gearing ratio, like those things, I don't think really matter. Maybe it's not smart to use the homing to move the stepper, right? Because like the homing that involves like speed, the firmware wants to move the stepper at a certain speed. So it might just be overdriving it speed-wise. Clipper, move, stepper, steps. Maybe there's a command that we can use to like just do steps. Force. I also had force move. Force move. Okay, we can just drop that in as a module. Okay, let me just drop that here. Move the stepper to given distance in millimeter. Oh, that's also why I didn't know the set kinematic position we wanted to use before. But this also involves like millimeters, right? So my idea was to like, say like do 100 steps. Let's see. But let's use this set kinematic position then. Then we also can move without homing. That's like the trick I wanted to show before and failed horribly. I see here. Oh, I tried that at some point. So we can just say set kinematic position x, y, z, 0. And now you will see that like all of them will go to blue if it would know the command. So that was not part of the force move. Oh, we have to do force move enable. Oh, okay. Is it then true or something? It's not very specific. Yeah, here he says true. Okay, let's try that. Yeah, now it works. Okay, that was missing. So now you see it's like fully homed. I do not know if Flip can do it. Yeah, like the kinetic position basically just says like wherever you are, that's your position now. So it just homes it basically. So now we can move it in very small steps. It might just be way too fast. Yeah. I mean, now we can move it, but it's like really not doing anything. I said no to 1%. I feel every individual step. We actually see here like how it ticks up. Like every time the number changes, I feel like a tick, 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 tick. Okay, but I think this is like easier to test. So let's do the following. We already disabled micro steps. Rotation distance doesn't matter. That's only like for the millimeters later, right? Full steps for rotation. Also, that's like only like when you like want to translate the like movement of the stepper to like a distance, right? But it's not super important for us at the moment. Gearing ratio is the same. So we still have the step pulse duration. And it's stealth drop, right? At the moment we have stealth drop actually on. So let's just disable that and see what that does. Did it not restart? I'm sometimes not sure if it restarts. Because like it does permanent. Oh, because it's still moving. It was finishing the move before it does the restart. In general, spread cycle more provides greater torque. Yeah, exactly. That's also what I said before. Like basically you're trading like the noise level with torque. But I disabled it before, and it worked like less well with stealth chop on, off. Let's see. Let's try this again. I mean, now it kind of does something again. But see now it gets, do you see like how it moves? Like it kind of moves fluidly, but then it's kind of like stopping. Let me do it again. I mean, it should be one continuous movement. I'm not really concerned about noise, to be honest. Like, I want every bit of power out of these like super weak, flimsy things that I can get. I mean, building this printer, like, because like, I want to build a printer with that, right? It's not about like performance or noise or anything. It's just like for the fun of it in the end. Let's see. So I'll just dial down the speed to 24%. Let's try. But also with less speed. But I feel like we're getting closer. So stealth drops off. Run current we can still up more, but it's not running fluently yet. So having more torque. Let's actually just put it to 0.1. The rotation, full step rotation. Let's try that to be 32. I don't know, like I don't think it makes a difference, to be honest. It's just like the print, like the stepper will move not as far as the firmware thinks, but I think now it will just be like trying to move it faster. Yeah, now it's way faster. Like you hear, like, or I hear the whizzing. Now it's just like vibrating in a very high pitch way. So now it's way too fast. Yeah, even if I set the speed now to 10%, it's really just vibrating. Now something is happening at 4%. But again, like it's not like at the very least it must be like a fluent movement, right? It can be weak and everything, but it needs to be fluent movement. And you see, like it's not anything but fluid. I mean, the wiring is correct, I think. So that's a good first thing. I mean, what we could do, because I don't trust those DuPont cables really, because like they're super flimsy in here. So potentially there's not like a good electrical contact in those cables. So I think what would be actually a good step now, because we know the order of things here, is that we just crimp like a JST connector on that we know we have a proper electrical connection. I think that's actually like a good thing to do. So let's quickly do that. We leave that plugged in here. Let's actually just fully unplug that. And then let's just like cut it off the cables here. And then we see the relation between the jumper wires and what we had here. And I know that like when I used those motors the last time, I went through the exact same thing. Like it was exactly that, like they moved somewhat, but not properly. And in the end, like they were quite strong. Like you can actually like pull stuff with that. I built like a camera slider with one of them. So definitely it's doable. We just need to figure out the settings. So cut can't wait to do more crimping. I mean, the other thing we could try, right? At the moment we drive them with 12 volts, but I don't think it makes a difference if we lower the voltage. We could try it, but I don't think it makes any difference. Okay, this is... Those cables are horrible to crimp. Now I lost my... Ah, here it is. Yeah, amazing. It's crimped, but the wire broke off. So you must not use the small crimping setting. With those. Let's try the medium one. Yeah, the medium one works well. Okay. Quickly do the rest. In the end, I actually want to use Marlin for this printer. The goal is also like to have like little test beds for Octoprint on Marlin. So, but I figured like in the beginning now to test stuff, it's way easier to use Clipper because we can iterate quite quickly. But I'm already like a bit scared of like having to transfer the settings we now find to Marlin. In the end, we also will use a different board, right? We will use the Ender 3 main board and not the SKR Mini E3 we have here, because this one has 2 blown stepper drivers, so we won't be able to use this board. That means also we need to later figure out how it works with the... I can't remember the model number, but there's a different driver type on the Ender 3 mainboard. But I think if we make it work now here, like... Oh. I damaged the cable a bit with the crimping pliers. Okay. It's good enough for testing. Okay. Then, when we plug this in, we plug it in like this. Black is the first, which actually is blue, which I have in my hand. So blue goes in first. Did you crimp the wrong connectors? No, this one works. Okay, so pink is the outmost one. I think we need to recrimp the blue one. Then pink is the outmost one. And orange is the third one. And then blue. I think I crimped the wrong connector on blue. It looks smaller than the other. Oh yeah, it's the smaller one. Oh shit, we have to recrimp that. It's also like cut off like the damaged cable bit. Hey. Oh, but by the way, motors have 30. Oh, one printer using these motors said motors have 32 steps per turn. The gear is not exactly 1/64, but for the first run and test it will be okay. I recommend using 1/16 microstepping. Yeah, but it's kind of like what we have at the moment, right? We turned off the microstepping. But that's just, we can put this back to 16, right? But before we do that, I just had like kind of like thought. Wait, where's the tab where we? I just had the video open of that guy, right? And I showed the mainboard, or he showed his mainboard. Let's quickly check if at some point he, yeah, here. This is his cable thing. And I wonder now, should we just copy what he has? Because mine is different. I have blue, orange, yellow, pink. Let's copy what he has. Let's crimp that, and then let's put the connectors exactly in that order what he has there. Oh yeah, I picked the smaller size. So let's crimp that, and we have to quickly. I saw in one of Steve's last streams, it might have been the latest one, that he has now like a tool to undo JST connectors, and I definitely want to get one too. Oh. And that's just, seemingly I need a lot of attempts today. Okay. Let's quickly get those out again. Which I hope I can do without re-crimping them. Here we go. See if we get the last one as well. This one puts up a fight. Put the camera a bit at an angle like this, then I can lean forward to see what I do, and you necessarily don't have my head in frame. Here we go. Okay, and then let's use a knife to just go behind the little noses to just put them back up. bit much, but we'll be fine. Perfect. So now I'm looking at the screen, and he has as first one orange, as second one pink, then it's yellow, and lastly blue. And then we can, I mean, compared to what we had before, let's quickly check whether we still have the 1, 2, 1, 2 polarity thingy going on. Wait, so this one? No, those two are now one. Okay, so now basically it's like 1, 1, 2, 2. Okay, let's see. That's interesting. So let's plug that in. Power on the board. Connected. And let's see what happens. So I'm back at the 16 microsteps. Jonas, I completely ignored your comments. Here on mod there is also another good picture. It says yellow and orange belong together and pink and blue is the other call. Yeah, exactly. Like we had the overview of which calls go where already. Somewhere I had this in the documentation. I used thick needles for undoing the JSTs. It worked pretty good so far. Usually like those tweezers also work quite well. Like now it took a bit longer, but usually like using those, it just kind of okay. But there's like this specific tool, like it's mostly something you get quite cheap. Not even what I want. Yeah, basically like what Steve had, it was like this, but then like multiple next to each other. So you press once and you remove multiple at the same time. This might be something, because I already have the Molex removal tool for like the I don't have one right now, but like the bigger plugs. Actually quite cool. Like I got it from a PC modding store. And it's really cool. Like it's like customized. Like they wrote my name there with addition. Pretty cool. Like if you need like sleeving and stuff, MDPC, I think MDPCX is the store, is really good. And I also have this tube used for the old school PC connectors. But I'm still missing the JST. Where were we? So 60 microsteps, rotation distance 8, most likely will be 30. Oh no, the 8 that doesn't matter for now. Full steps per rotation is 32. Looking at chat, ballistic tech said 32 steps. We have that 164 and 60 microsteps. Let's save and restart. By the way, can I navigation? There's this option to remove the sidebar. Here, icons only. Yes, I like this much more. Try again. Most like whenever it's like stuck in this blue one, I think it's like the connection isn't good. Here we go. Okay, let's do our set kinematic again. Now it has like heavy coil wine, but that's what we want to see. So the cables were wrong. Yeah, now like I can't move it. Like now it really grips. Okay, so now we can tune the values a bit. Firstly, let's do one thing. That's also something I do on all my printers. Like, I mean, like the switch wire I actually use in Stealth Shop because like performance is not super important. The V0, what I have, like the problem is, and I'm not quite sure if it's a clipper issue or in general, like now the motor is like just a holding current, but it's really noisy. It has this like whining sound. I hate it. Like I really hate it. So what I do always is I set Stealth Drop to 1. So basically, if the motor is standing, you are in Stealth Drop mode, but if the motor is moving, you go to spread cycle. Yeah, now it's silent. I mean, it's still like holding very well. It's just like, it's really annoying if you have this whining sound. So, yes, I use it on the warrants too. Although I might run the V0 in Stealth Drop at the moment. Don't quote me on that. On the switch wire is in Stealth Drop only. Because they're like, the motor speed is not super critical, I think. Because like it's the bed slinger with the heavy bed, like it's kind of slowish anyways. So like having the spread cycle power, basically, that you don't gain a lot, I think. That's just my personal 2 cents. So the rotation distance, I think that's actually something we need to do really at the end. Like if we have like a working printer, we need to check the rotation distance, because also like the, where do I have it? Like these basically, right? Like they go on top, you mount the belts, and like they also influence the rotation distance, I think. Like it's what I thought about like this morning. Like basically, if you have like a super like wide wheel here, right? One rotation of the motor will like move the belt much further than when you have like something like this, like 20 tooth, right? So most likely we will need to wait for rotation distance when we have like the final part. Those are not 3D printed. Or what do you mean by 3D printed? Like, sometimes I forget words. Like that thing is metal. But the final one, I think we will 3D print them actually. Because the shafts on those motors are so short. I mean, usually what the Voron folks do, like they mount one in this orientation and one in the opposite orientation for the AB belt, right? But now the grub screw is already above the shaft here, so that doesn't really workable. But I actually tried 3D printed ones this week. They broke because they were too weak. But I'm pretty sure like for the final thing we will print them just because we have to in a certain sense to make the small shaft work. Okay, so let's quickly try to tune that a bit. So the run current, I think we can put to oh, now it's that time again. Like sometimes during the stream, for some reason, and I never figure out why, like my shortcut keyboard stopped working. Like basically I have this like shortcut keyboard thingy I built to control the scenes. And it works in bringing up the correct program, but like it doesn't switch the camera scene anymore. I never figure out why that happens. Where were we? So basically the run current we can put to 0.2. I think that's safe from what I saw. And then the micro step 16, that's all fixed. Step pulse duration, let's not worry about that. But then I think spread cycle, running them spread cycle is fine, and 0.2 run current. So I think that's a good setup. So let's do set kinematic position. Yeah, I mean, that's not like a speed you can actually work with, right? And it also has like some grip here, so. I just set the speed to 200%. Maybe that is not the perfect step or two to test out speed, because here we have like quite heavy limits on the axis. The motor also doesn't get super warm. Like it's like barely warm. It's good. Let's quickly turn that off. And move that from Z to... Ah, shit. X and Y are both broken. What a shame. Well, then let's just remap it in software. So I just want to quickly hook it up as like X or Y stepper, that we get like a little bit more speed on it. Let's first, I quickly save this configuration just so that we have it. You can just change the pin in Clipper. Yeah, exactly. That was my idea. I just changed it in software basically. So what we need to do for, let's just change it to Y. So we just switch this one and that one and this one and that one. It's not changing the pin, but should work, right? I can also up the speed limits. But I think now it's fine. Like now, Y is just this one. That should work perfectly fine. So let's quickly do set kinematic position. And then let's just move. Oh. I didn't like that. Oh, what's that? Huh. Let's go for the upping the speed limits. I quickly restore what we had. And now basically, let's just see, where does it configure that? Here, max set velocity. Set acceleration, let's just say, I don't know, it doesn't really matter. 1000. But let's use the max acceleration here. Let's just set it to the same values as the other ones. Unlimited possibilities, yeah. What's the saying? All roads lead to Rome. Also exists in German. Alle Wege führen nach Rom. Let's see. Nope. What did we break now? Oh. What's the problem? It was 2K instead of 3, like on X, but it's fine. Oh, yeah, then I mistyped, but it should be fine. That's why, like, the first IT question, like from IT support, is always, is everything plugged in? Yeah, now it works. Oh, but now it's like just beeping. That's too fast. Let's put it down to like 6%. Okay, so there's the speed limit, and we definitely like we are definitely too high now. Yeah, I'm Michael. That's a SKR Mini E3 V2, which is badly damaged. So I use it for like testing out weird shit. The first and the second stepper driver are both blown out. We killed that board, or I killed the board. Wait, can you see it? Oh yeah, see here, there's like the residue of magic smoke. Like this one also like is super hot. Like the X stepper is like boiling hot. It's just like shorted out. And the Y stepper we figured out earlier doesn't work. So this board's just kind of like toast. But I use it for testing purposes. Whenever I don't want to risk killing something, that's good. That's the board to use. Let's see, so this was... Okay, 25% speed is already too much. Like it buzzes, but it doesn't do anything. Let's try 10. Yeah, so 10% works. Let's try 15%. 15 also works. It still has like torque. Let's try 20. Oh. Also works. It's actually quite fast. Try to scratch off the surface and reconnect the traces. I'm pretty sure that the driver itself is toast. Like, this is, you see like the rough surface there, like the entire driver is just toast. You actually also see here like where it blew. Like this thing, like technically you can like remove the driver and solder on a fresh, like a new driver and the board will be fine. But it's just not worth the effort. Like I can't do it. And actually also the fan 1 and 0 MOSFETs, you see like the two green LEDs, they're both broken as well. Like that's like where I used it for testing and something didn't go wrong, go right. So this board's just toast, but it's okay. Like that's like cost of hobby projects. So 20% is also fine, but we knew 25% didn't work. Yeah, now it doesn't work anymore. So somewhere around 20% is the limit. So that's 21%. Just kind of trying to like figure out the limit. 22 doesn't work. So I think if we calculate 20% of the max acceleration speed we have at the moment, we are fine. That should be said. Yeah, it's definitely that. I'm not sure if I have it on camera with the magic smoke, but it's part of the Switchwire stream. So what happened to that thing? And it's like absolute me fault, or me problem. This board was installed in my Switchwire, and I was like setting up that Core XZ motion system, and it was like running very smoothly. And I'm like a little play child, you know, like I like to play. And I was moving the printhead manually, just to see, like, you know, like it felt nice and was like very smooth, very nice motion. And yeah, guess what happens if you move stepper drivers and you have a board connected to it on the other side? Induction is a thing. So yeah, that's what happened to this stepper driver. Nobody else to blame but me and my stupidity. But yeah, technically, yes, I know you can easily replace it. Like if you have like, I guess if you have like a hot air soldering station and you have flux and you have the part and you have skill, it's very easy to replace. I have neither or none of those things. I have neither or nor a hot air soldering station. I don't have the chip. I could buy it, but I also don't have the skill to do it. But it would be actually like a fun thing at some point. Like maybe we can make like a stream out of that, like trying to repair this board, like replacing 1-2 stepper drivers and the small MOSFETs here. It would be actually like a fun project. But yeah, so I broke this like the board like, quite some time ago actually. I kept it because at some point they always come in handy. And I also still have this original Ender mainboard. And this is the one actually we will use for the printer later. It's even simpler, but like that's perfect. You get those for like 5 to 10 euros on eBay. So if you want to build a printer for 100 euros or less, this is kind of like the only option to go. But yeah, you see like the layout is the same. So that's fine. And yeah, I kept those. Things like these I always keep, and then after some years I throw them out, and then like a month later I need them. So let's see. So basically speed-wise we know 20%. Oh, 1 second, I need to reconnect stuff. Oh, I also see. Oh, the music wasn't in the stream. Not sure for how long. I think of reviving my old printer, which I built myself, but I have to build a PLC first for it. Remind PLC? What does it mean? So right now, like we use Clipper. Just like I figured it would be easier to use Clipper to like A, the board was flashed with Clipper, but B, it's like easier to change configurations on the fly using like stuff on the fly. So, but later on, my goal is to use Marlin because I want to use this like printer we create as a test bed for Marlin and Octoprint. Oh, SPS. Okay, see, SPS I know. Just briefly, there have been some dropped frames. Okay. Let me know if that happens again, because now I'm like changed the microphone, which means I changed stuff on the stream. So in case you have more drop frames, let me know, because last stream we had like tons of drop frames and it was like really horrible. And I changed settings and hopefully it's fixed. Okay. Greetings from Netherlands. But I'm from Germany originally. So that's why SPS means something to me, while PLC does not. Let's see. So the velocity we set here is 300, so 20% would be 60. So it won't be a fast printer, but an acceleration, let's be realistic and just say like 600. Let's quickly see if we can like run that. Oh, we need to home first. Let's see. No, it's a bit too much. Ah, weird. I think now the acceleration might be too high. Ooh, now it gets really toasty. So that's 14%. Okay. So it's still 20%. Let's see, what did we do here? I mean, the acceleration might be the problem, right? Let's just put the acceleration way down. And let's home again. So the acceleration is now 100. Oh, wow. The acceleration was the problem. Now it also like turns faster than definitely before. So let's just set the max velocity like to 120. Let's leave the acceleration for now. But yeah, for stuff like that, Clipper is way better. Like if you want to like iterate quickly on settings and stuff, like just imagine every time we change something, we have to compile and flash the model in firmware. So let's see. Still kind of the same. Let's just quickly try 150%. Okay, 150 was too much. Try 120. Also too much. Okay, so seemingly 100% is kind of the limit here. Let's try what happens when we like lower the velocity even more. The acceleration, I mean. Let's just set the acceleration to 50. And see if we can now push the absolute speed a bit more. But it's like already way faster than I expected, so. But now the motor gets also a bit warm. But I think like we overdrive it a bit, so. Now it notably took longer to accelerate. Yeah, no, like it stopped moving. So I had 133%. So I think we are still 110% works now. Let's try 115. 115 is too much. So technically we can add a bit more speed. Let's see what happens when we move more than 25 millimeters. So we always move 25 millimeters. That's kind of in air quotes because we never like really configured like the movement distance. Let's just move 10 centimeters. Okay. Oh, I think we need the. Wait, let me show. G91 to set apps like relative. Then we need to move and then. Yeah, now it works again. Okay, so let's just move like 200, just like a long distance. Oh, out of range. I'm very sorry. I am very sorry. Okay. Let's just move the opposite direction now. So it's happy. And let's set the speed to 115. I just want to see like if it has speed time to ramp up. No, doesn't work. Okay, so 110% is really the maximum. So I guess the max set velocity we could set to 130, but then like we're really on the edge, right? So maybe it's better to just leave it at 125 and say like, hey, that's fine. But the problem is like now that we're like trying this out, this really depends now on the other settings we made here, right? Like especially the rotation distance. Oh, sorry, I forgot to switch. This really depends on the rotation distance because like this is millimeters per second, right? What unit is that? What unit are we talking here? Yeah, millimeters per second. So basically, that really depends then on the rotation distance, because rotation distance translates the rotation to a distance. So it doesn't really make sense now to like really like figure this out, but nevertheless, it's interesting to see. But once we kind of like calibrate everything, we need to wait, I'm trying to move it like that's like not doing things I want. Okay. So the acceleration also is kind of on the limit. I set it back to 60. Yeah, I feel like we should leave it at 60. That seems like a good value. The motor does get warm, like noticeably. So it might be something to consider later. I mean, firstly, that means we definitely need to print the motor mount from ABS, which I guess was already given more or less. But overall, like I'm really happy. Like this works way better than I expected. Cool, perfect. Okay, that's kind of like, I hope it wouldn't take like 2.5 hours, but here we are. We have a working stepper driver. So the important part is we now know the wiring. We know it works, right? So this is kind of like the proof of concept I was looking for. Like we can use those motors. We need to see with like the amperage and how hard we can drive them, but like it will work in some way or another. Like might be very slow, but you know, it's more about the concept and the fun of building than like the final product in a certain sense. Cool. Yeah, and again, like one of those motors is like €1, basically, €50. So they're dirt cheap. But what I want to do is I want to design the printer in a way that it accepts these motors, but also ideally accepts the NEMA 17 or NEMA 14 stepper. So if I want to, I build the printer and like it maybe turns out okay, who knows? Then if I really feel like it, I can just like throw like another €30 worth of stepper motors on it, and I have something that I can use in a daily life. There's also like the mounting holes, I think actually like match. Oh, that's funny. Almost. So it might be quite easy to just incorporate like mounting holes for both of them. Then you can, because like the, what do we have here? I think that's like 28. It's a bit wider, but not by much. But then basically like what we can do is like we can have like the 4 holes like this, and then like basically when you look from the top, just have it like this. And then also the shaft is almost in the, I mean, we can position it in a way that the holes are aligned, or like not quite aligned, but like next to each other. And the shaft is basically almost in the same position. I think there would be like a really strong case for having NEMA 17 and this support. And then like really like if the printer is okay, if the motion system is okay, you can throw on bigger motors and you have like a proper printer. Maybe just like for the fun, I actually, oh, it's, yeah. So just like to quickly show what I was thinking. So let's just close all that. And So this is my BOM, my bill of material. So basically, like the parts I was looking at, like total price at the moment is 100 euros. I must admit I cheated a bit because I just put the fasteners and cables to 15 euros. But I think it's actually quite a fair price. Like you need to like buy like a couple of like screw sets most likely. So the total price you spend might be more than 15. But you will have like tons of stuff to spare. So basically like the belts, I was looking for the cheapest GT2 belts possible, like super crap quality, but like 5 euros for 5 meters. I can add a link here later. The hot end, we will use the CR10 hot end, like the Creality CR10. Because it's dirt cheap. Sorry, my voice is breaking a bit. So what I found is like for 6 euros, you can get like the whole assembly. Prices fluctuate a bit, so let's see what it is at the moment. Yeah, at the moment it's 95 cents because I'm not locked in. Welcome deal. But yeah, you see it's 5.71. But this basically includes the hot end with the heater and the thermistor, the heat break, the heat sink, everything. And also comes with the Bowden tube and the cables. So that's amazing. So we can use that. And why the CR10? Because the CR10 uses 12 volts, which matches our stepper drivers perfectly. So that's why we go for this package basically. And the main board is the Ender 3 main board. Basically, then the stepper drivers are the ones we saw. We take 5 pieces because I read that they sometimes are a bit iffy. Like some of them are not really good with the gearing. So just one spare. Then basically what we will use is these aluminum profiles. They're like round profiles from the hardware store. This piece is like 3 euros. So it's 1 meter. And that's what we will use basically to like build the frame itself. Then fans are a little bit special. There are not a lot of 12 volt fans in 3010 size. What I want to do is I want to use the Mini SB Bowden as a tool head. Just like for coolness, I guess. Yeah, it's basically this tool head here. It's like the Voron. Oh, you don't see it. Wait. This is the tool head. So it's just a normal tool head. Normally goes on the V0. It has a Bowden, not a direct drive extruder, but it's fine. And then basically like we need those fans. And they were like a bit difficult to get in 12 volts, but I found some. Extruder drive gear is like the normal drive gear that you use for. I think all the Vorons use them. Oh, these are the belts, the wrong link, the springs. Oh yeah, I clicked the wrong link. So we use, yeah, this set here. Again, like, welcome deal, yay. But also regularly it's not 12 euros, so. Bed springs, no bed springs. PSU is the only thing where I don't save money on. I just go for like a Meanwell LRS 75, or this 15 is the wrong link. But the 12 volts is the same price. So, oh, it's actually quite cheap here. I think I have it listed as 20 euros here. But yeah, 75 watts is more than enough because we don't have a heated bed. So it's just the hot end and the steppers, and it will be fine. And then like end stop switches, panel connector, and that's it. And then you end up with 100 euros, which should be fine. Like, will be nice printer, I guess. Nice is relative. And then I just have like a couple of upgrades. So I will use printed bearings. I was also thinking about the laptop PSU ballistic tech. I actually thought about, I put them back, but they are like those enabler, PD, how are they called? Trigger. I thought about using these. So basically it's like these little teeny tiny boards. I actually have them, like they're really cheap. And basically what it does, it just tricks a USB-C power delivery charger into delivering a certain voltage. And I really like to use them actually for powering hobby projects because you get them with like different voltages, like 15, 9, 20, and it will just poop out the voltage if you connect it to like any like USB-C laptop charger. The only problem here is that most chargers do not support the 12 volts rail because the 12 volt rail is optional in the PD standard. So most chargers just skipped over it. So 12 volts is pretty much the only one you don't get. Then I was thinking like you can combine that with a buck converter to step it down from 20 volts, for example. But then like, yeah, I don't know. Feels not very nice. Like technically, yes, you can save money there. Instead of like 20 euro for a PSU, you could combine that with like 2 or 3 buck converters like in parallel to have the proper amperage, right? Like I think those like standard ones, right? What can they do? I think they can do 3 ampere or something. Yeah, 2 ampere. So technically, if you just set 4 in parallel or something, you're also fine, right? And then these are like, yeah, let's say like normally they go for euro. So then you have like for the enabler board, euro, so 5 euro, and you have like a 12 volt power supply. But it's a bit cheating because then you need a laptop charger. So yeah. And I just felt like the Meanwell power supply is like proper. Like it's the only part I don't want to like cheap out on is the power supply. Because it's just like, yeah, I don't know. There's one thing I noted here, like what I found on AliExpress. I was looking for that. Like for LEDs, you get, again, like these are not the real prices, but like normally it's like 3-4 euros. And okay, at the moment sold out, but you get like 100 watts for like 5 euros. But then like I don't trust it. Like this is not what I want. Maybe change the rods with linear rails for an upgrade. Yes, I think that would be an option, but I don't think linear rails are easy to integrate because like they work completely differently than the rods, right? Like from how you construct the printer with the linear rails would be very much different than with the rods. But what you can do, that's something I thought about, like instead of like the hardware store linear, like instead of the hardware store rods, they're like aluminium, weak, not perfect. What you can do is actually, you can get a SMOP, yeah, you can get a SMOP. Smooth rods, 8mm. You can get these. I mean, it's just a rod, but they are like more precisely machined. The Prusa Mark 3, 4, they used it for the bed motion, for example. Like the print bed on the Prusa machines runs on that. That's actually like quite a good thing. I think it would be like equivalent with linear rails if you combine it with like a linear bearing. Like these are linear bearings that go onto them. Then I think like from a motion ability, it's kind of like equivalent with a linear rail. I think he meant an all 12 volt PSU for pre-USB laptops. Yeah, I also thought about that, but then like if you buy it new, like those like they also run you like 10, 12 euros, and then you can basically just like chip out like a bit more and you have a proper PSU. But technically, I mean, what I have here, right, like this, if it wouldn't be for the hot end, this would be enough, and you get those for like 3-4 euros as well, right? You can also use 2 of them, and then you're also fine. I think there are many ways to do it a bit cheaper with the PSU, but I felt like cheaping out on a PSU is not really worth it. But yeah, like I mean, like that's really up to whoever wants to build that. If somebody wants to build that, right, like you can really replace this 20 euro thing, and instead of the 20 euro, you get the print bed or whatever. Because as you maybe see, we do not have a print bed in that list, and that is because we have to 3D print our print bed. And it also will not have a heated bed. It's just like, it will just be like a printed bed with like painter's tape. But yeah, that's like one of the upgrades I have, like aluminum build plates. You get them for like 15 to 20 euros. It will be like the V0 size, so like 12 by 12 centimeters. And then you can also go for a heated bed, either like AC or DC if your PSU you got here is big enough. But it's just like a work in progress kind of thing, but these are the parts I kind of like have in mind. And let me quickly see. So, I mean, I did a little bit of fusion work. By a little bit, I mean a little bit. But it's basically all I have so far. I started this week. Wait, let me hide those. Joint. So basically that's what I have at the moment. So that's the XY joint. I will maybe try to adapt for plotter. That would actually work quite well, I think. You can just leave out the Z. That would work really well. And the things like because of the rods, it's really easily scalable, right? Like if you just make the rods longer, you will have like a larger size. That should work really well. Yeah, but that's kind of what I have. So you see here, those are those linear bearings. But keep in mind that we use printed ones. So I really try to like cheap out on every euro except for the PSU. So we use those. These are 3D printed, and I found the model on printables, and it works really well. Like it's a really smooth movement. Like oh, that's the end with the sticker. But it's a really like nice smooth movement. Like it's really like little resistance. And there's not a lot of like play. I mean, they might wear over time, of course. But this is like a very, very nice, smooth movement. And because like you kind of like have the gravity preloading it anyways, like even if there's a little bit of play, I don't think it's like super horrible. And then you also have two in parallel, right? So I think this will be fine. But it's actually like a smooth transition. So basically this is what I designed so far. So you have the two rods top bottom. Oh, no, I have to go back. The two rods top bottom. And then on the side, here that is where the X rods are basically clamped. So this is Y. And then here on the side out is X. Easy, just print new ones. Yeah, that's also what I thought. Like, printing them is like super quick, so even if they wear out over time, like, yeah. And because they have the same dimensions as the proper like LM8UU bearings here, like these are like proper bearings, like metal ones. They're like €4 to throw in, right? Like if you feel like you really want to use this printer, just spend €4 more and get like metal bearings with balls and stuff. But you can also do it later, right? Like it's just a drop-in replacement basically later on. Yeah, and then the other things like the roller stacks here, they're also printed. And this part here is the same 8mm rod. So really try to like minimize the hardware needed. So my goal is to only use M3x12 screws. Like this M3x12 screw is used everywhere so far. And then like here the stack is printed because like if you start buying like the ball bearings and stuff, like it really gets expensive. Like it's like €5 here, €5 there, but really adds up. I was thinking about using these like what's again 608ZZ bearings. That I use those because they have an inner diameter of 8mm. And you get, these are dirt cheap. Like you get like 20 for like €5. But for some reason, I mean, it's just coming down to tolerances, like this doesn't fit. This doesn't fit on here. It's ever so slightly too big or too small. So that's why I ended up with the printed bearings. And I did some testing with that. Like this is basically the bearing stack. This is the same part that you saw in Fusion. It's like the spacer on the bottom, and this one is the roller. Like this works really smooth. I made it in a way that only touches in a couple of spots. Like you see this ripple pattern around the top. And that works really well. So this is basically my idea. And you can tune the preload. Yeah, actually like, let me quickly hold it up. Yeah, and the tool head also, like, you can actually save money on tool head, right? Because the tool head has 3 fans. You don't need 3 fans. You can remove the part cooling fans. You save another like €5. But yeah, I thought it would be funny to have like the proper Voron tool head on there. So actually what I want to do, yeah, as you see here, like this gray part, this one here, where on the bottom you attach the bells, and on the top it's mounted to the linear rail. And I want to copy this part into my project. So basically that the same mount exists for my printer as for the V0. So any tool head that goes on V0 will also fit on my printer. That's kind of like my idea. Let's quickly check that. Sorry, my voice is dying. I think it was this one. Yeah, it was this one. So the guy basically made already like different sizings, like 8, 10, 20, 30, 40. And you can just try out which one fits well, because it will really depend a bit on your printer tolerances in the end. But also I noticed like they wear down in the beginning very quickly. So basically when you first put it on, it's quite stiff. And then you move it up and down for like 20 times and it like becomes very smooth. It's just like, I mean, it just sands down like any part that sticks out in a certain sense. But yeah, you can like basically use that to also tune your preload, but just be aware that if you have like a preload from like friction, it will just wear down really quickly. Yeah, so basically what I want to do now, after showing that here in Fusion, I actually have those parts all printed. And I just want to quickly try out whether that fits, how that fits, and whether this is like a proper way of clamping things together. If that works well, like with my tolerances I chose here, you see like where it clamps. Here there's like a bigger gap. So let's just try that and just assemble that block, which is, I'm actually very happy with the design. It's really blocky, so I might work a bit on that. But overall, like, I mean, I'm happy that I got it together in like a quite compact form factor. So I'm happy. But yeah, let's build it. So let me quickly clean up a bit. Oh, and I actually have to take the rest of the parts from the printer. Give me 1 second. So, the only thing to consider, I printed this in PLA. Later on, we might want to print this in ABS, but there will be a small difference. Like black is ABS. I have this like second bearing here in ABS, but this already fits quite well, to be honest. And then basically we just clamp that, which also somewhat fits. Oh no, I'm an idiot. I printed the same one twice. I didn't mirror it. This doesn't fit together. Let me quickly start that again with the right part. So we're missing. I mean, there's not really like top or bottom. Let me align that. So we're missing the bottom one. Okay, that's already like a lesson. Yeah, it's already a lesson. A couple of lessons here. So basically what I do is I use a script to export the bodies. That's something I started doing with my PC case that I built. And you see like all the bodies with like E in square brackets basically are exported. And you see the bottom mirror part doesn't have this E, so the parts didn't get exported. So let's just throw this one, quickly save as mesh, and send it to Orca. Yeah, that's the mirrored part. I think the clamp is the same. Or at least we can just flip it. Yeah, it's the same. So, where are we? May I select this? Okay. Okay. Let's quickly print that. I have to turn on the printer. Let's quickly give the printer a second to boot. I didn't realize you had so much CAD and printing done. Well, so much is relative, right? I designed one part, and then mostly yesterday evening. But it was just like, for me, like this XY joint is really important because it's like the proof of concept, right? Like it proves that the linear bearings work. It proves that the stacks, like the roller stacks work for like routing the belt. And it proves basically kind of like the general concept of my CAD skills. And yeah, that's it. It's just like, I think it was like an interesting part to design. I also want to do like a lot of CAD work on stream, actually. That's kind of like my idea. Like I don't have tons of time at the moment, like outside of the streams. So most of the progress of this project will be in the streams. I might make the streams a bit longer, so most likely we're going back to like the 4 or 5 hour streams. But most progress will be made on stream. Printer is booted. Let me quickly remove the prime line and stuff from the printer. 1 second. Yeah. Shortcuts don't work. And I touched the bed, and the Z stepper skipped some steps. So we need to quickly redo that. It's not properly homed. Let me just emergency stop that. And then let's just print that again. Cool. Okay, then let's put it together. I think the first part, or first step we need to do actually is to cut some of the rod. So let's actually figure out, like, the idea here is basically that the rod is sitting in this like cavity here, and it's basically clamped down with the other part. And actually just check if that fits, because I already see like this is like super, I don't know, it's like an okay fit. There's a bit of tolerance. So basically the challenge we have here, is that some parts need to be really clamped together, right? Like you really want to have pressure on that bearing, but at the same time, the same parts hold this like bearing stack in place, right? But what you want to prevent is that like you put pressure on the rod here, but the bearing itself is loose. So I always have a bit more like tolerance here, because like for this like vertical connection, it's not super important if it's like super like fixated in XY, neither in Z, right? Like the belt will just hold it in place basically from the tension, so that's not super important. Now also here on the side, I also, you see, I didn't use circles, but I used these like somewhat misshaped octagons. So basically I really put pressure only in the corners, just to like have like a proper clamping force. And then, yeah, that goes in like this. So let's just cut the parts of that. And this can only go wrong. So I have the absolute wrong tool. But this is the saw we will use. Let's cut some stuff. Let me quickly check Fusion. I think the length, what we need for the vertical ones, is 20. Wait, 26, if I remember correctly. 26, yeah, 26 millimeters is what we want. I think it would also be very advisable for me to design like a jig to like cut those things. But for now, let's do it manually. Ballistic Tech, your gift comes on stream for the first time, I think. Ballistic Tech sent me this Voron ruler. I really like it. It's amazing. I don't know, when are you planning to release the files? Files for what? For this printer? Like, all I have is what I just showed in Fusion. Wait, where is Fusion? Wait, this is all I have. This is what we build right now. This is really like a work in progress. Like, this stream is not about building the printer, it's about designing the printer. So you will have to wait a little bit longer, I fear. Okay, so this is like a really rough measurement, but it doesn't need to be super precise, I hope. Yeah, so Nefnif, you need to be a little bit more patient, unfortunately, with me. But I will do my best to do it quickly. But yeah, so the height of those, I'm a bit limited here because there's like something. The height is not super important. So my idea is with all those rods, like, because I will cut them by hand and my cutting skills are horrific. There must be like quite a bit of tolerance in the length of the rods. So let's just make a bit of space. And let's see how it goes. Okay, now we know how not to do it, because this is like a really horrible cut all around and it's not straight. But it's like the thing, like I don't rely on the end tips of the pieces, because I knew how horrible it would be if I cut it. And I'm definitely sure that this is not the best tool to use. That's one thing I can say with full certainty. But it is in the, I mean, you basically have like 3 millimeters up or down. Wait, where's the second bit? Ah, here. So that's basically just like held in place here. And like, even with this horrible cut, it's still like intolerance. That's how I try to design the parts, because like me cutting that, not good. Okay, let's do one more. We'll try to make it a little tiny bit longer. I will definitely create a jig, like to make cutting them straight easier. And at the proper length. I think that would be like a really good thing to print. If you just have a jig where you like put it in. Yep, that's also just long enough. Cool. And then basically we can assemble like the bearing stack. So we have one spacer and one roller. And that just goes in here. And then technically this part just comes on top and clamps everything in place. And then like once we have the bottom part, like that's the wrong part, like then the same on the bottom. And here on front there's the second bearing stack, which we actually can already put the parts in. So there you just have the spacer on top. By the way, again, I'm trying different materials, like the black one is ABS, and the blue one and the green one is PLA. Yeah, and basically like this would then go here, and then you're kind of like ready, right? So I'm a bit in doubt like cutting that. I mean, like it's not expensive, so we can just get more. Because technically I want to have like two parts here, right, to clamp that and test like the x-axis. I'm just wondering how we should cut it because I don't know yet the total length. When building something out of similar rods, I found out that one of my hardware stores is actually rods, not pipe. And I think that may work much better for some parts. And was not much more. Yeah, actually, like I saw that. They were not more expensive. They were stainless steel, actually, I think. Let me just like open the hardware store. And most likely I don't find it now. So I shop at hammer.nl. And I don't speak Dutch, so it's always like a little bit challenging. How did I find that? Profilen font. Here, exactly. Like you see here is the solid one. It's also aluminum, but it's 4. But I saw them in person. Like there's also 10mm ones. I just wanted to go for 8mm because I can also use them as a vertical axis for the stacks easier. If it's like 10mm, it's like even thicker. But let's look for stuff 8mm. Yes. Okay, even if I don't find them now, like I saw them in person. That's not what I was looking for. I saw them in person, and yes, they were not much more expensive. Like maybe like 5 instead of 3, something like that. But what I found is like they're much heavier. And I wasn't quite sure because like I mean it's kind of like a flimsy construction overall. That I think like maybe having the aluminum ones is better. Especially for X, where like the steppers have to move the X-axis back and forth, right? So I thought maybe it's better to have those. But I mean, like whatever floats your boat in the end, right? Whether you use those or like solid ones, it's exactly the same. Like you can also do the thing that I suggested here, right? You can once we know the length, you can order like I try to make it like, or like I will make it like a proper length. So it's like 15, 20, 25mm. Then you can order like proper ones, and they're also not expensive here. Like, I mean, again, this is not a real price, but they're not expensive. So you can order like those smooth rods properly that are like really meant to be used at something like that. Whether it makes a big difference, not sure. Also, the ones that are blank may be... What do you mean by blank? And for the bearings, I actually ordered bearings myself. I will try out whether the printed ones are better or the ones I ordered. But yeah, like the LM8UU bearings, they're also not expensive. Like you get those 10 sets, basically. That's I ordered one of those 10 packs. Because basically we need 2 and 2 for Y, right, on both sides. We need 2 for X, 6, and we need 2 for Z, so it's 8. Yes, mine are sandblasted. That's actually also something I considered. That actually would be better if they're not sandblasted. But it's kind of like what I got. And again, like this is just like for testing, basically. I might go for something else later on. That being said, let's actually see. How about we just cut like 2 10-centimeter pieces for the demonstration of the x-axis, and 225. $230. Let's just cut 230 pieces for the y-axis, basically, and then whatever we have left, we just halve it. I think then I still kind of like try to cut it in a way that like what I cut now, not only for testing, but I can also use for something. Okay, let's quickly cut that. Let me also switch back to the desk view. But yeah, like having like a jig to cut them definitely will help a lot. Actually, yeah, something like this would already work. Like if there's like a gap in the middle, like just like that both parts are fixed in a certain way. Maybe it even makes it easier to hold. Okay. Reasonably the same length. Or some kind of smooth, wait, some kind of surface treatment. Yeah, I'm pretty sure like that's also like what I noticed with the printed bearings, right? What I mentioned, like they basically sand down a bit over, like in the beginning, like very quickly. And I think it's just like because the sandblasted surface is a little bit rough, like it just like acts like as a sandpaper a bit. I actually did not check the print at all. Looks good. There's some blob here, but looks good. So yeah, like having something smooth, like I also checked only one store. Like I will just check a little bit more, but like I want something that's very easy to get. And I think like this in general is very easy to get in some variation. Let's see, how much do we have left? A bit more than 30. Let's just cut 2 pieces of 15. And those 2 pieces we can use for the demonstration of X. And then I'll clean up here a bit. Already learned the lesson. Like, it's way easier, like once it's cutting in, like to just turn the rod instead of like pushing the saw forward, and you get like a nicer cut. Okay, let me quickly get all this like aluminum dust out of my table. Actually, the first time I used the saw. Hey. So yeah, that's almost the perfect size for another stack. Okay. I think I'll just use like wet towel. Give me a second. So, a little bit cleaned up. This is pretty good already. I sawed mine by hand. Yeah, that was the option. I have one handsaw, but then I think this would have taken like a long time. But I think if you really have like a jig where you like put in the rod like this, right? And you just have like a guide for saw blade, and you can like saw. This will be like really easy to saw. Like aluminum is quite soft, and that being hollow really helps. So I think then you can really saw it by hand and also like quite precise and straight. But again, like, I mean, I'll try to design it in a way that it's like not really needed to be super precise. So you can just move it around to make it work. Okay, how long does it still take? Oh, 20 minutes. I need a faster printer. How about we start putting in heat set inserts and putting at least the top together. So, and I also need to find M3 by 12. Because I was not smart enough to get some. 1 second, let me quickly grab those right away. I should have thought about that before designing everything for M3 by 12, but I only have those M3 by 12 left. We need to see if we find some more somewhere else. Okay, cool. So this is ready. So it's quite a lot of like screws and heat set inserts and lock parts. I'm also like really tempted to print it in PLA, I must admit. Because for one, I have like these like pastel colored PLA spools. Like I have the blue, the green, and I think lavender color. I kind of want to use it for this like printer. I don't know. Like I think it would be like a cool color scheme. But also like PLA is cheaper than ABS. Yeah, 1% and much cheaper than I thought before buying it. Wait. Much cheaper than I thought before buying it. I would have expected it to be more expensive. What do you refer to as being more expensive? My blade is dull and was not hollow. Well, that sounds like a lot of pain. I was like a couple of weeks/months ago, I added this like transparent bottom panel to my V0 roll, which I cut from acrylic glass. That was absolutely horrific. That was before I had that saw, like the jigsaw I just used. And I cut it by hand using like a handsaw. Man, that was like horrible. It really took forever. Oh yeah, these were all the heat inserts in this part, actually. And something warped a bit. But should be fine. So then I think we can just put this together here. We still have enough screws for that. And then we need to find some. Just first, put them in. I'm always like amazed when you design something in Fusion and like it just fits. I don't know, like, yes, you saw it in a computer, but I'm always amazed, like, if it really just fits. And also, like, I didn't expect the round part to print that well, to be honest. I expected more problems with the overhang. Okay, let's just tighten them, like, over cross. Kind of get, like, equal pressure on all sides. But I already see, like, I didn't expect this to, like, close up. So this means that we need to have more separation between the parts, because I don't want the parts to touch. Like, because now, like, the pressure is between the two printed parts, but I want to have the pressure on the bearing in the middle. But overall, like, this is working pretty well. Like, there's a little tiny bit of gap around. Like, I made it maybe a bit too close. Like, maybe I can increase the rounding here a bit, because I really don't want to touch it there, right? We want to only ride it on the bearing in the center. Let's install the X-axis here. We just have to find. Oh, actually, we can use shorter screws for that one. For this one, we can use shorter screws. Oh, the rods, yeah, they're really cheap. They're really, really, really cheap. I was also quite surprised. But acrylic is also super bad to cut. It melts into the blade and makes it dull. Yeah, also, like, what the worst part about cutting acrylic for me is actually the dust and smell. But what I figured out is if you have water on your plate, it's way better. Like A, it doesn't melt, and it also captures all the dust in the water. That was actually like a lesson I learned. Like always cut acrylic wet. It really makes it way better. But I'm pretty sure like the first time I cut it, I didn't use like a respirator mask or something. I most likely shortened my life by like 5 years by inhaling all that. Oh. Okay. You can over tighten that. I mean, still, but that's kind of what I wanted to know. Like, technically you can pull it out, but it's okay. But it's like really restricted in the movement, so I think this is fine. But it's a good lesson. So now we know where the part failed. This is a very good lesson. So basically now we have a split here on the side. But it also means maybe that the gap here is a bit too big, right? Yeah, so basically now the bottom part split off. So not sure if we can make the part much stronger there, to be honest, without making it much bigger. But we can reduce the gap a bit, right? That's harder for you to over tighten it. Okay, well, let's just put this together for now. But it might also just be like a print orientation thing, to be honest. But the problem is that if you print it in a different orientation, I fear it will crack in the middle. Because now it was printed like with this surface down, right? So layers go like this. I mean, you see it here. But I fear if you print it in a different way. I mean, we can print it like this. That's what we see. We can print it like upright, like this, right? And the layers go like this. And I'm pretty sure it will split here in the middle. Yeah, these are two orientations you can print it in, right? Okay, so this part we need to improve a bit. Because I feel like you need to re-tension that to have it like properly restrained. But seemingly not too much. Okay, how long does it still take? Still 10 minutes. So let's maybe see in Fusion if we can make that a bit stronger. How we can improve that. Just quickly collect the parts. Just quickly collect that a bit. And then maybe like when the printer's done with that part, we can directly print like our revised part, depending if we find a good solution. Here we go, Fusion. So I mean, one option would be to make the part stronger, right? The other option is to make the part more flexible. Because like where it broke now, maybe it wasn't so smart to put all parts together so we can't look at it anymore. where it broke now is exactly here, on the top, like here down. That's where it broke. I mean, firstly, what we can do, I mean, the gap here is the same, but let's just double the width here, that we really have like a little bit of a gap there. Yeah. So basically the position of the parts is defined by the bearing. That's fine. And then here the question is, A, do we make the gap a bit smaller? Because like things like there's not really like a pulling force on that, right? Like you just have to restrict it in like the Z direction. And it's actually like a little bit, That's the thing now here, right? So, I mean, A, it's split, but B, it's also like a little bit wobbly. Which is not ideal, of course. Like, that's exactly what we don't want, right? Like, this needs to be restrained. So now the question is this because, I mean, this is obviously like not properly tightened right now. So let's do the following. Let's replace this part with the one that's still intact. Because one lesson here might be that we need to make this deeper, right? Because this is not super deep. I'm actually like, I'm not sure why I made it even. I mean, there's like way more space here. We can move further back. Oh, no, we can't because the bearing inside is there. That's where the bearing here is. But this is not like a lot of like overlap, right? This is like a centimeter of overlap. Maybe that's not enough. Maybe we have to extend the part further out, right? Like if we make it 2 centimeters, like it's like already less opportunity for movement. Plus the part will be stronger, right? Like the split we had here now maybe doesn't occur. So that's, but yeah, there's really like a really big gap. Let me try the following. I don't have a washer at the moment. I was thinking of putting a washer in between. Let's use this little thingy. Just as a spacer. Just trying if we put pressure on it, whether it will split. Maybe screw into the rod. Yeah, I thought about that, but I did it for a project before, and I found it really difficult to drill into the rod. But that will also be, of course, an option, right? I mean, we have enough like room here that technically we can also like, I mean, if you have a jig, right, where you have a jig with a hole and you can drill directly in the center, what you can do, of course, is like drill through the rod and like mount the rod down. That would work. Yes, press the load a bit too. Yeah, exactly. Like if we just have it like a bit longer. My concern is just I kind of want like the overall result later to be still quite compact. And if we add a centimeter here, right, this means the overall printer will like grow by 2 centimeters in width. Let's actually maybe also try what happens if you only put 2 screws. Yeah, it's still like quite... I just fear that if I tension it more, it will break. Let's put the other screw in. I mean, it's better. It is better. Definitely better. But I think what we could do is if we widen this by, let's say 5 millimeters, right? 5 millimeters should be acceptable. It's already 50% more. And then we can like spread those screws out a bit, right? Because we have more space. And then what I would do is I would remove that, like at the moment the screws are sunk in. I think I would remove that outer part here. Make the part a bit more flexible, that it can bend easier, because right now it's very thick and can't really bend. I think this part benefits if we make it flexible, that it can bend. Because then it can like push around the part. But to be honest, like it's already like almost tight here. Let me just try what happens if I... Yeah, now it splits again. Okay. So we were just on the edge. But it splits in the exact same place. I wonder if it's also just that we created like the perfect weak spot. Because where it splits, it's basically the level of the inner plane, right, where the screw head sits on. But it's also the exact layer where we are on top of the rod. So basically we only have this very narrow band holding or pressing down, and the other part is pulled down. So I think we just created like the ideal weak spot here. Let's do the following. Maybe 1 centimeter long apart. Yeah, let's see. Like, let's try half a centimeter first. I mean, it's a very small part. We can iterate on that, right? But it might also be uneven load for sure, or uneven pressure. Let's see. So what we can do. So the first thing I'm thinking about, let's go before we do the fasteners. Now all the fasteners are gone. And then we can go here. Okay. So because we basically put this in here, right? Like if you look from the side, this is really exactly this like level here where it splits. Maybe 3 screws is better. Not really sure. Just a gut feeling. Yeah, that's also something I thought about. Like if you have one on top and two on the bottom, because then you don't push on the exact opposite sides, but like overcross a bit. So what I was thinking here, I mean, what you can do, I mean, also looking at the screw heads here, right? Like, even if you want to have it flush, there's still a bit of... Oh, I'm showing the completely wrong thing. I'm very sorry. Even if you want it flush, like there's still 1 millimeter of a distance. So having this might already be way better. If this is, let me just quickly see where we... Wait, we can actually modify the parameter. Screw head height. We had it at 4. Let's just put it for 3 for now. And then this should... have moved out. Didn't. Wait. Let's see where I do that. Here, yeah. Or at a clamping ledge in the part. That would also work. But I don't think it will like help with the pressure. Like we can reduce the hardware used, which is an honorable goal. See here, I didn't use the variable. Minus screw head height. So now I think this already helps. By the way, is my Fusion the only one that sometimes like really screws up the rendering? Sometimes just misses faces. Because, I mean, now we just move the screws out 1 millimeter. But I think what it does is if you look at this distance... Wait. At this distance, like from the inside where the rod is, now it's 1 millimeter. Which means like 5 layers. At the moment, the part we are having is 0, right? Like if I undo the changes I did. See now here, that's what we have at the moment. The distance from this like inner surface where the screw mounts against to this surface. I mean, it shows now the vertical. It shows now the vertical distance. Because it's exactly on top of each other. Like it's the exact same layer. I think that is why it splits. Let's quickly do this. I redo the change I did here. And the printer just finished. Let's print 2 parts with a very slight modification. Where we really only have this like 1 millimeter separation. Save as mesh. Let's quickly send it to Orca. Do we want to, yeah, we want to print it like this. And then I just create 2 of them. And we quickly send that to print. Let me quickly grab the parts we printed and clear the print bed for that one. Can you show again where it splits? Yeah, it splits directly here. you see like it's the inside is exactly like the top layer of the where it like clamps the rod. But if I pull this apart, you see that's also the top layer of the screw. So it's the exact same layer where you have the top of the rod and the screw pulling down. So it's like the perfect splitting point. Like here you push in and here you pull down. Like it's the same layer. You really like just pull them. I think not using 45 angle but round maybe help it to not split. Yes, it might also help a bit. But to be honest, like looking at this part, like there's like in reality, not a big difference between rounding and 45 degrees. Because like you will never have a perfect, like if you print it in this orientation, like with this facing down, you will never have a round top here, right? I mean, you could print it in this orientation. Then you would have like a perfect rounding. My idea was just like the rounding is never perfect, and I rather would have like a defined pressure point. Okay, let's quickly see what the part I'm printing now does. That might already solve the problem. Yes, so now we have a mirrored part. So let's put this in. Let's quickly loosen it here. I was thinking that the pressure point is the issue, but not sure. But it's definitely the issue because it's the same. The pressure point at the moment is the weakest layer. Because it's like the layer with the least like surface area to like press, like to attach, right? It's the layer where you have the least material holding it together. And it's a layer where you push up here in the middle and you pull down here. So it's a perfect splitting point. So it's not even about like the flexibility of the material. By the way, it's also like something we could do, right? Like to make it more flexible to bend. At the moment we have this like solid part here in the back, right? So the part is very stiff. But if we hollow this one out here at the like just like have this like rounding go all the way through, like the part should be more flexible to bend. That might also be like an improvement. Okay, let's just quickly put this together because I'm interested to see how the bells work. So let's just drop this in here. And then we can put this on top. And then we put this here. Put the bearing in. And let's see if that goes together. Yeah, here we go. Let's see. For now, I will only use 2 screws here. Let's actually check if we still have like M3x12 flying around somewhere. Oh, there might be already one. I have tons of M3x8. But M3x12 is not in the card, I think. Yeah, let it flex around the rod. Yeah, that's exactly what I think. Like if it's more flexible, it doesn't split, it just flexes, and that's perfectly fine for that part. Yeah, I have tons of M3x8. Oh, here, M3x12. Perfect. Let's use those. Just need to make sure to like later put them back, because like these are like from the V0 and I kind of want to keep the spare hardware of the V0 together. Oh, I also forgot we first have to add heated inserts, right? And there's still like no heated inserts in here. Okay, let's quickly put it together. That's a lot of heated inserts for like for heat. I never show it's heat inserts or heated inserts. But either way, it's a lot for this single part. Cool. That's all in. Now let's put it together. Hope the screw heads fit in there, because they're a bit bigger. Yeah, barely. You have to convince them a bit, but they fit eventually. This one doesn't go in. That's the corner where it warped a bit. Yeah, let's accept that this one doesn't go in. I don't think that's mission critical now for the path. But I think it's important to just have like a little bit of like an even pressure distribution there. Hi there, Wes. Been looking for a few minutes how it's going. Well, I think so far really good. Like we managed to get the stepper driver going, or like the stepper going. So we have working stepper. We kind of assembled this like very colorful x-axis, which also goes quite well. Well, not x-axis, like the xy joint. So yeah, going well. It's the first stream of this project. So basically we're trying to build like a sub €100 Core XY printer. Check the printer. Oh, Check the printer. Thank you. Yeah, check the printer. Sometimes I have really high trust in my printers, and sometimes it's just not warranted. What a shame. What happened there? Let me quickly clean up the mess and then we can try again. 1 second. Okay, let's try it again. Thinking, shall we do the same one again? Let's maybe just half it and just do one instead of the 2 parts. And let's also just pay attention a bit. Let's just move it down ever so slightly. Because also notice like this part here is warped a bit, so I think the bed adhesion is just bad for some reason. Like this one rolls much better. So really like also like learning. So like the hind one has a bit more friction than the front one. But I think this is due to the material. Like the black one is ABS, so I think it's a bit tighter from the shrinkage than the front one, which is PLA. But basically, I mean, generally it runs really smooth, I think. And yeah, these are gate spells, but we will not use gate spells later on. We will use the cheapest piece of crap we can find. I mean, interesting will be like how to route it, right? Because later you have to kind of like push this through here. But I think you can always like just use a pair, like just something to like force it in here. Like this will be like a bit of a pain. But I guess you can also pull it through and then feed it in this way. Yeah. I think it's doable. Yeah, but also this one runs really smooth. Okay, let's keep an eye on that printer here. Yeah, it's also like running really smooth. Like no complaints. I think this is definitely working as like a low-cost bearing stack. This definitely works. I really wonder, like in the end, like if this is all put together, like how much worse is it than like a proper Voron, for example? Your print failed. Yes, it failed. I see your efforts. Impressive. Thank you. Thank you, Wes. How come the clamp is splitting? The problem is that basically the pressure here in the middle, you have here the pressure in the middle from the rod. I mean, that's my theory. The rod puts pressure directly here in the center, and the screw is putting pressure from the top, right? Like forcing it down. The problem is that this is all in one layer. Like the force up and the force down is exactly like on one layer. So you create the ultimate weak point here. So what I did now, basically, I just moved the screw thingy like 1 millimeter up. So you have a couple of layers just to bend. PLA also writes much better on itself. Well, I was thinking about lubrication, whether we need lubrication. And I think I would not add lubrication, like neither on the bearings, like if it's printed bearings, neither on the bearings nor on the stacks. Because what I learned from the V0, I had a faulty lead screw there. Like the lead screw was ever so slightly too big, and I saw dust on it from like the POM nut rubbing, like the plastic nut rubbing on the lead screw. And then I added like grease in my thinking, like to make it run smoother to prevent the dust. But what LDO told me later is that by adding grease, I made it even worse, because the grease captures the dust and creates like sanding paste, basically. It makes it even worse. So I think we just don't do any lubrication. But I mean, we can also mix materials, right? I'm not sure if I would recommend that later, like, because like more different materials add cost in a certain sense. But you can also say like the main part is ABS, but like we recommend PLA for the bearings, right? Because they run smoother. It's self-lubricating. Yeah, that's actually interesting. Like PLA. I really would like to print everything in PLA, to be honest, because it's just like a simpler, cheaper material. Not sure if that will be possible. A custom core XY printer. I didn't see it coming. Well, me neither. Hi there, Sven, by the way. I missed you. Jackson too late. Going to start from the beginning. Good evening, Chris. Good evening, Sven. Yeah, custom core XY printer. Like my idea is like my couple of motivation points. Like firstly, I have the stupid stepper motors since years, and I kind of want to use them for something. And I had in mind doing that like last year, just like not a Core XY printer, but just like a super simple like motion system. Because I developed my app like Octo app, right? And at the moment I don't have any Marlin printer. I only have Flipper printers. And I thought that like I need a Marlin printer. Just like sometimes you need to test stuff. So I was like, hey, like let's just build like a simple motion system out of those stepper motors and the old Endo mainboard I have. But then basically, like last week, Thomas Landero, Made with Layers is the channel now. Like he posted this review. Wait, like actually quickly. We have to wait anyways. Let's see. Yeah, here exactly like this video. And I saw that, and I kind of remembered my idea. And this printer is using, and I'm fairly certain that this is the exact same motor as I have here. I'm fairly certain. Like you even see the cables, right? No, but this one is a little bit different because this one only has four wires, right? No, it has 5. I see a yellow wire, I see an orange wire, I see a red wire, I see a blue wire, I see a, yeah, it has 5. So this is also unipolar stepper. So this one here, I'm pretty sure that's exactly the same. Maybe it's a 12 volt variant because I have the 5 volt variant, but besides that, should be the same. Can you not control the preload by allowing the gap between the design parts 0.5 and allow it to bottom out against the housing? Well, that's a thing. Technically, I can, of course, control the gap, right? I can control the gap basically and also like limit the load. But firstly, what we saw is that even briefly before the part failed, we still had a little bit of wiggle on the rod, so it wasn't quite tight enough. So I don't think that we have enough pressure on it in a certain sense yet. So I think we need to find a way to make it more resistant to the pressure. And I think like now what we did is we removed this weak spot. And then what we also briefly discussed is that at the moment we have this U shape going on here, right? Like the part has this U shape. So what I would do is I would remove this back part here, like the the hollow part where the rod sits in, I will just move it all the way through. Like the rod can't go deeper in because we will hit the bearing here. So in this part, we don't have more space. That's the maximum. But on the top part, we can remove that, and that will make the part flexible, right? So it can just like bend around the rod. And then you will kind of like, yeah, you allow the part to deform, because at the moment it's very stiff because it's very thick, so it can't really bend. But if you remove this like bottom half, basically, you will create this bending, like weak spot point where it can bend. I think it will work. And then the other thing we discussed, but that would be like a bigger print now, and I slowly want to wrap it up in the next half hour, is just to extend this, right? At the moment we only have 10 millimeters here of overlap. And I think we definitely need to make this 15, maybe 20. I'm just very hesitant to adding space here, because if we add space, that means that the overall printer will be like wider. If we add like 5 millimeters here, right, the overall machine needs to be 1 centimeter wider to have the same motion range. And I kind of want to keep it compact, but I think like this is just not enough overlap, so maybe we need a little bit more. Like maybe 20 millimeters would be the smart choice, just like to prevent any wiggle here in this part. Change the print orientation so that the layers are not trying to be separated. Yeah, the problem is with the print orientation. At the moment we print like this, so the layers are, yeah, you see like how it splits, right? The problem is if I print like this, that I have the layers not separating here, that you have the layers like this way, then you have a layer split most likely here in the middle, right? Because you put pressure left, right, and it will bend around this middle section. That's my fear, that we don't split it here in the middle instead of here. Let's see, like the part is ready in the next minute. Let's see if the new part fares better. And maybe we can modify the new part even. Let me quickly try it here. What happens if we just snip here? Yeah, I think we can even add this modification to the part. And remove this back part here. I mean, now this was already split, that's why it falls off. But I think if we remove this back part here, the part will be more flexible. Let me quickly grab that. I'm right back. Okay, here's the new part. So basically now the only difference is that compared to the old part, you see like this indentation here is less. Is 1 millimeter less. Maybe you see it, maybe you don't see it. So let's just quickly take the screws we have here. And let's just put in a new part without any further modification. Let's just quickly put it in place. Oh, sorry, too tight. Okay, too bad. Yeah. Okay, now it's all the way in. Let's see, let's just tighten it all across. Yeah, it still splits, but it's way later. Okay, it still splits here, but also I think my theory is correct because it splits on the front. I mean, maybe because I now tightened it here on the front first. But it splits way later. Like basically now we are completely tightened. Like there's no gap anymore. It's also like way more stable. Huh. It's way more stable. Okay, I think if we make this part like a little bit better still, we might not need to add more distance. Like it wiggles a bit, but it wiggles even the gap here, so that the rod is completely safe. Do you see that? So I think this is now tight enough. Ah, that's the oh no, wait, it's not the screw that doesn't grab. Just wasn't tightened properly. Let's tighten that. Must have skipped that. Yeah, it's really secure now. I think this is fine. Do you need to recess the screw heads? No, technically I don't. This is a purely visual decision. Because I kind of liked it to be like, you know, flush. It's a purely visual decision. Also the screws are long enough, right? Because these are M3 by 12 technically. And I actually added like, for them to recess, I added like a lot of like extra hole in the back. We don't need to recess. That would actually be like a really perfect fit to not recess. Where's my calipers? Like, this is 8 millimeters. So the without recessing the screws, they're the perfect length, because like 4 millimeters will be in the part in the thread inserts, which is 4 millimeters tall. So it's ideal length. So maybe not recessing them. Which would be a shame, because it looks nice. And see how you can make a form with the same later. Like, to be honest, if I have the choice between not recessing and making this wider, I take the not recessing any day of the week. It's just like, it would be nice for it to be recessed like this. But of course it's not required. So shall we do one more attempt? So this might screw up a couple of things with the fasteners if I remove the recess. Yeah. This will screw up a couple of things. But let's just like ignore all the fasteners and stuff. Nobody needs it anyways. Oh yeah, it also, just for testing, I will patch it up later. Let's just recess that by 0.1 millimeters. So it's recessed, but technically not. Just for testing. And then the other modification we do is, if I roll the history marker here, you see this face here. We just push this to object. We just push this all the way here to the back face. So So you see the red part here. So we remove this back bridge just to make the part a bit more like flexible, that it can bend a bit better. Save as mesh. Off we go to the slicer. Oh, wait, I did something wrong. I saved the whole thing as mesh. We only want this part, please. So. Oh, it's missing. Oh, wait. Can you make the part thicker to the top? Technically, I could. Then maybe try printing other orientation. Wait, let's first fix this. Okay, now we have the whole part. That sometimes helps. Save as mesh. 1 second. Here we go. Now we have all the holes. I mean, orientation-wise, what can we do? We can print it like this. No, definitely not. What is that? This is the orientation we printed so far with the bridge to the bottom. I think that's the best orientation, to be honest. We could print like this. That's the best orientation. Ha! Yeah, of course. Sorry, I'm stupid. This is the best orientation because now like the layers are. This will work. This would work even with the recess. I guarantee. Sorry, like my brain sometimes is not so fast. Like, yeah, this is the orientation to print. Because now you have the layers like with the thing. Oh god. Wish I could do the same magic with Fusion 360 like you. To be honest, it looks like more magic than it is. Like I'm still learning a lot. Like the files I made for the PC are barely editable. Like they're really horrible. But like I'm by doing that, I learned a lot. Like the thing. Like wait, let me show it. So for example, like with the. Let's just go all the way to the end. So with the PC case, for example, I started using those fasteners, which are actually super easy to do. You just have this Warron plugin here, actually, which is super handy. And just a parts library with all the common printer parts. So you can just search for M312. And here you have your M3 by 12 as a model, and then you can just import it with one click, and then you can just place it. Now with the 3D printer, what I did, I moved the parts around, and then, so basically I took it, and I moved it, and there's some like move tools to align it, but then basically it's just in place. Now what I started doing with this one, for example, I now use joints. Like you see all the joints here on the bottom. Now basically what happens is like the part is like attached to the other part. So if I do stuff like changing the inset here, for example. Wait, up. Which one was that? This one. If I change stuff like here, this like inset, which we now change to 0.1. Let's just change this back because I'm pretty sure it works to the screw head height. Now you see all the screws like automatically like move in as well, right? Because they're attached to that surface. So that's what the joints are doing. So step by step, I'm learning. Yeah, let's see. Like it's, I think you only get better if you do it or like use it. Cool. I'm also like, I expected to have problems with this rounding printing. But now seeing it, it's perfectly fine. The only thing we should do is I would make that a bit bigger. Where do we have that? And yeah, the files are quite messy. It's not perfect by any stretch of the imagination. Yeah, let's just add like, I mean, looking at this here, quite tight. Let's just add like 0.5 millimeter to that. And see, yeah, everything explodes. That's what I expected. Yeah, maybe that splits the 4 holes then. Yeah, let's see. I mean, now we have the stronger part, right? Okay, I think now I fixed it. Yeah, it's like not a very like straightforward way to construct that part. I'm pretty sure like you can improve that many ways. Okay, but now like we have a little bit more. You see now you see the bearing inside here, so we just have a bit more space. So we have more tolerance without touching the rod, because I don't want to touch the rod here, of course. I want the bearing to be the only contact point and not like any stupid part we put around the bearing. Cool. Let's see, is our printer exploding again? No, it prints fine. The only thing the only thing I forgot. There's still the skirt of the previous print. Oops. Yeah, it could be worse. Okay, let's prepare it. Yeah, but actually, like already now, it's much better. It splits. It splits, but you see there's still pressure on the rods, because there's like this like couple of layers that are, you know, like the screw pushes on from here down, and then there's like those like 3-4 layers that still go over the rod and push it down. I think that's the main difference why it's now very like fixed in place, and before was not. Because before no layer was going over the rod anymore after it was split. Yeah, like this is really like fixed in place. I don't think we need more distance, which is also good for the ends, basically for the Y rods, right? Like those go in here. I don't think we will need a lot more space there either. That's the thing, right? This is already like kind of like the whole printer. Like lengthwise, I hope it's not gonna be much more than that. Pretty sure it will be less, actually. Let's see. Yeah. A bit hard to move now, but it's also like the rods are not really put in place. Like individually, they move very smoothly. You just have them like to like mount them properly on both ends, of course. Let's see, how long does it still take? What does it say? Five minutes. Okay, then that would be like my last attempt for today. Also depends on the screw. If you have flat ones, it should not split. Well, I do have the socket head screws, right? The only problem with those is that they generally have like a very small head, like from diameter perspective. So on the bottom here, there's not a lot of like room where it is put on pressure, right? If you have the button head, they have a larger area on the bottom. You can really see that. Like they have a bit larger area here on the bottom. So they distribute their pressure over like a couple more layers, which doesn't really make a huge difference. It's just like maybe like 3-4 layers more, but I mean, it's 3-4 layers more. Yeah. I'm really curious, like, I kind of want to, the next part I want to design, like I would call this done for now, like we can improve it later. Like if we have this fixed in place and everything works, I would print one more prototype basically. I would just do it tomorrow. Like I just print all the parts one more time just to sanity check everything works. Then I would call it done. The next part I would design next week then basically on stream, I would assume, would be the front idler, right? Like we have this front idler here. Let me just show it like maybe on the V0 in Fusion. So that's the V0, right? And what we designed now is this part here, like this junction basically. This is what we designed, this part. Actually, just like for comparison, like how big is the one from the V0? 30 millimeters, minus 44. So yeah, that's just the like size that will be added to the total printer, right? Maybe I can get mine a bit smaller, but I think I don't have too much chance because the bearing is already 24 centimeters. Then if you add like 10 more just for the screws, yeah, I don't think you can remove a lot of room there. But yeah, so that's that. And then the next part I want to design next week then basically would be the front idler. So that's this part here. Wait, can we remove the panels maybe? The frame, panels and clips. Nobody needs panels and clips. Also top hat. Yeah. So basically this front idler here, that's what I want to design next. I mean, you see here, this part is like way more complex. So the front idler should be a walk in the park. Basically all we need to do, like here we use the 1515 extrusions, right? So basically here there would be our rods that need to be clamped there. And then we need to have 2 rods and 1 rod that goes down like for the Z. And then we just need 1 bearing stack here to like rotate that. And that's really it. The only thing I want to prevent, you see here the V0 actually has 2 different idlers on the front. You see like the distance here and the distance, yeah, the distance here is way less than here, right? Because this is the top belt and this is the bottom belt. I would just want to have them the same and mirrored, and then basically just the stack with like a spacer and a bearing, and then like you just flip the stack on the 2 sides to have like the 2 different belts. So I just want to have those 2 parts identical. That's the only thing I want to try to achieve. Yeah, that's it. But then that's next stream. I'm pretty sure we get it done and prototyped in one stream. Like my idea is basically to build stuff like on Fusion, what we do now, but also print it like live. Next time I just put the printer here next to me, then we don't have to like walk around, and I also see if something goes wrong. Yeah, but then basically that would be next stream, and then after that, that's like I wouldn't say the most complex part, but here the motor mount on the back we need to do as well. And here the challenge will be like that I want to support different sizes of the motor. What's the plan for the Z? For the Z, like I'm stealing, I'm getting inspiration from different existing printers, of course, right? Like I'm not reinventing the wheel. What I want to do for that, like it needs to be cheap, it needs to be simple. So what I want to do is I want to copy the Rook. Oops. No longer on printables? Uh-oh. I think printables has a problem. Okay, then I can't show it. But basically the Rook has a belted Z. So basically like the bed. I kind of want to show it. Oh, you know where I can show it? It's stupid, but I saw it on Steve. On the thumbnail. I saw it recently. No. Maybe I didn't. Okay, maybe. Yeah, but that's already good enough to show. So basically, see here the Rook, they also use the rods actually. So we will have the same 4 corners. Oh, try to rotate it. And then basically the bed runs on the same bearings on the back. You see here like the bearing. And then the motor sits down here. You see here's the motor. And then there's just a belt running in a loop. And the belt is fixed on the bed. And that's basically an Z. So the motor just pulls the belt, which moves the bed up and down, that rides on those things. The fun thing that now see it, like I was thinking whether just having 4 rods is strong enough. But obviously, seemingly it is. So I was thinking about having like some X here or something, but seemingly that's good enough. The only thing is like on the bottom part, we will also just have 1, 2, 3, 4 rods connecting that. So I don't want to have like a lot of printed parts in a certain sense, like big printed parts like the Rook, right? Like everything here is printed. I want to minimize that as much as possible. And then the electronics either go on the bottom, but I also was thinking about just putting them on the back. Let's see. Like the PSU will be on the bottom for sure, just for weight. But then maybe the electronics on the back. Let's see. That's something I haven't figured out yet. But yeah, so basically belted bed. Okay, let me quickly grab the thing. 1 second. Okay, here we are. New part, new luck. So basically changes are, we removed the backside here, right? So this is now like one like thing. So it should be easier to bend. And you also see the layer is now, this is one layer. So the layer lines are like this. Oh, like this. Okay. Close it out of the way. Let's just put it to the other side for now. And we now need to have longer screws. By the way, this is now like a perfect example where the button head screws are better, right? Because like they have like the bigger pressure area. That's exactly what I meant. Like if we use the socket head screws here, they maybe only press on like 2 layers on each side, maybe 3. And those press on like maybe 4 layers on each side. So it just like distributes the pressure a bit more. Yeah, I'm already like on the limit of tightening, I think. Yeah, this is a winner. And this is PLA, right? Like if you would print it in ABS, ABS is a bit more flexible. Like it's not like flexible per se, but it's like less stiff than PLA. Oh, interesting. See what's now happening. Like now this is completely tight. Like there's nothing. Now the part here splits. Interesting. Yeah, like now basically you see there's a bit of flex. Because this screw doesn't go in. That's that screw basically. And here it's not. Yeah, those screws don't quite go in because it's not designed for them. Ah, this one now does. But this is like super solid. Like you really know, this is like super solid. Okay, that's interesting. So we need to consider a couple of things. Firstly, this is like the perfect orientation. This is how we print this. So this needs to be in this orientation and with the hollow part on the back, and then we're golden. Oh, I actually put it on the wrong way. The chamfer is on the back, not on the front. Doesn't matter. So this is like really solid. Then the other thing is, this part is now the weak spot, but I'm not quite sure if we can do a lot about that. I'm actually not sure why this splits. I wonder why this now splits vertical. Like, yes, there's a lot of pressure here. Also, the rod stuff check CNC Kitchen knife sharpener has a bunch of friction fit holes that rods work really well. Yeah, I'll check it out. It's a good tip. I remember that video. I think you could get away with in some places with those if your print orientation is correct. Yeah, I mean, print orientation really is important for like those high pressure things. But like this is like a really solid connection now. Like this is definitely like how I want to mount them. This is really good. I would still most likely make it like a tad bigger, just like that you have more like flexibility with the rod length, right? Like if the rod length is like 2-3 millimeters off, I still want to have like a good grip. So maybe just like, I'll make it like a bit longer. I'm just not sure what to do now about this part splitting. Because like here, we can't do the same trick. I can't print this part in this orientation. Let's quickly check the slicer. Do we have the part here? Let's just quickly go back. Here's the part. This is how we printed it. And that's kind of like how I designed it to be printed. The problem is if we print this in, let's say, this orientation, right? Now we also have the strong orientation for that clamp. I mean, everything would work except this surface here. I mean, this is kind of like, this is edgy. But I think this would work, to be honest. But this layer for sure does not work. We can improve this a bit. But I'm just not sure if I really, like this is supposed to be really tight with the bearing inside. But I'm not sure. Like this orientation would be much stronger. Because then you also have the layers here like this. On the other side, I'm also not sure if this is a big problem, to be honest. I mean, yes, it's not nice that it splits, but it's not splitting in a way that's like really like integral to the part. Okay, that means for me, basically what I would do, or like what I will try tomorrow, just like as a quick trial, is like I will reset the screws again because I just like it visually more. This was kind of like the look I was going for, to have all those like socket head screws recessed. So I'll try it again, and I think with this print orientation we are fine. Then the other thing is, maybe I should also reduce the vertical gap ever so slightly, right? Because at the moment, what are we talking here? Like, there's quite a big gap because I want to have a lot of pressure. That is 0.6 millimeters. Maybe if we do 0.4, we still have enough pressure, but we don't have the splitting issue. I wonder if positron design would be cheaper. The primary cheaper aspect is less frame to buy and assemble. Maybe, but it's a bit too advanced for my first printer design. Maybe the second round. It's also like those like rods here, right? They are dirt cheap. They're really, really cheap. Like they are like €3 per meter. So if you go for the positron design, let's say you save 2 meters, then you saved €6. So it's not like a lot of like savings in the end. Like that's like also like, I mean, in the end, like every euro counts in a certain sense. Like, for example, like I try to like not use, like I'm not using like the normal bearing stacks here, right? Because like it's €10 you save by printing them. So it really adds up. At a certain point, I think like the return is not like really worth the effort in a certain sense. Maybe you need to do the Warren trick and split the part in 2 and print 2 orientations. Yeah, this is also something I thought about briefly. It's just like the question in this case is like, do we then just like put the pressure point somewhere else, right? Like let's say I split the part here. I split the part here. I mean, then basically we'll create a gap here. The good news is, oh, we also don't have any space there, by the way, because if you look at the part, right, there's the bearing on the back here. So we actually, like, it looks like there's a lot of like space, but there's actually not, because the bearing is there. What we could do, and it's also a Warren trick, right? You can strengthen that part, because while we don't have a lot of space here in the direction, what we can do actually is add a screw from here through the part. The part is 23 millimeters. So what we can do is we can add 1 screw, 2 screw, like from each side, to just pull the layers together. Maybe that's something that would help, right? The main problem then is like I try to limit the amount of different screws I use. And to fix this, we really, I mean, to be honest, like if you do it from both sides, it's kind of fine, most likely. Because the screws even overlap in the middle of it. You know what I mean? That like the screws just support the layers. They pull the layers together. They would have a heat insert on this side, and then like a screw coming from the top, and just supports the part here. But I mean, this is a really valuable learning, right? Because like this setup, we will have a lot in the printer, like these mounting holes. So we really should figure out the way to do them reliably. So for the next time, it works better. But I think this is already really good. Like we know that the layers need to be across the bar. And then I guess that's it. So I will work a little bit on that tomorrow, not too much, just a little bit more prototyping. But then for the main thing, next week I will not do anything because I really want to do it on stream. Oh, it's also interesting, by the way. The bars are not perfectly parallel. Like here we have, but I guess it's something that would be fixed if you have on the other side, the opposite part, it should space it out. But it's very important that those are perfectly parallel, because if they are not parallel, you will have issues with the X gantry moving along. So that will be actually something interesting to see. So most likely we'll keep this part and we'll print a second part anyways, but I will print the mirrored version that we have 2 already. And then we can try out a little bit here with how that behaves. Cool, okay. Then I have a bit of stuff to do for the weekend. Not too much, just a bit. And I think this was a major success. We validated this part here, which is I think one of the most complex parts we will need to design. The stepper works. The stepper is quite strong, or stronger than I expected, to be honest. So that also is amazing. And yeah, that's pretty much it. Then thank you everyone for tuning in, and especially for helping. I really rely on people sanity checking my work, telling me that the cable is wrong, and stuff like that is really, really valuable to me. Cool. Then Alex, yes, I'm using Fusion 360. I was showing that also just before you joined or something. I don't know. But yeah, this is the part in Fusion. This is what we use. We also iterated on that here. So I want to do that on stream, make changes to the part, print the changes, just iterate. Cool. Also, Jonas, yes, this part is equivalent to this junction here on the V0. It connects the X-axis to the Y-axis, and you have 2 of them, one left, one right. They're just mirrored, basically. So this is the part we're working on. My part is the exact same setup. You have the 2 bearing stacks, this one here to route 1 belt to the front, and then on the opposite side here to route 1 belt to the back. That's basically, it's exactly the same part. I kind of took inspiration. This looks just way nicer than mine. Cool, okay, then thanks everyone for tuning in, and see you next Friday. Have a nice weekend and a beautiful week. Bye.